Hey everybody, how you doing? Welcome back to Joe's Computer Museum. Now I say everybody, I'm looking at the streamy thing here and there's like one person on there, but if it's just you and me, one person, then great. So what are we doing today? We're doing just kind of a laid back chill stream. That's the newfangled thing the kids do today, isn't it? Yeah, just going to sit back, relax. We're going to reverse engineer a nifty little doodad. By nifty, I mean super simple, for a client. And then whatever else happens. We might put together some electronics kits. We might take out one of the old PCs back here and play around with it. We might just sit and chat and goof off. Who knows, whatever. Yeah, so let's get started. A couple things to start with. One, you'll notice I got a Twitter thingy up here. You can follow me on there to see kind of updates of what's going on. So it'll be easier to get updates about the YouTube stuff on there actually than me creating the little reminder videos, whatever. And then up in here somewhere is a Patreon thing. If you like what I do and you want to help me keep doing this stuff and keep making awesome content, you can hop on over there and contribute, you know, like $1 or $1 million, however much you want to do. And we will do that. So let's take a look-see at the things here. First off, what are we doing today? So we're going to put together a little doodad, or we're going to reverse engineer a little doodad, then we're going to create its replacement. So let's go over to the bench here. Let's see if I can switch that. Is that working? It looks like it is. So here's the doodad we're going to be working on today. This is the remote for a Craftmatic 2 adjustable bed. Yes, I kid you not, a Craftmatic 2 adjustable bed. So the gentleman brought this in, and you can see it's in cruddy shape here. And he's like, so this thing keeps breaking, and it keeps not working, and this and that and the other. And we've done a lot of work for him on this. We've had to take these ends off here, cut them off, replace them several times. And we've also had to get in here inside the thing and resolder the connection on here several times, and yeah, it's just, it keeps falling apart. And he doesn't feel like trying to get a replacement remote. He wants us to just keep fixing the remote. So instead of just fixing the remote, I'm going to build him a new one. In order to figure that out, though, we got to reverse engineer this. Now, I have already looked around the inside of this a little bit and done a little bit of work ahead of time to figure out exactly what the thing is doing, right? But I wanted to show you kind of the process I went to here to reverse engineer everything to figure it out, and then what we're going to do to try to create a replacement for it. And hopefully it doesn't take 6 hours because I'm kind of slow. So here's the device. It's a very simple remote. I'll get all this junk out of the way. We don't need that stuff. Simple single-sided board, nothing crazy on it. A buttload of diodes, and a 6-pin phone jack on the end of it. Peel this back here and you can see it's just a single-sided board with the simple pressure dome contact buttons there, and the gold contacts all over the place. Now this thing only has 5 buttons on it, but you can see that this remote was either generic or universal, or designed for multiple different versions of their beds that had multiple features, and it was easier just to spin one board and then just set it up so that you know, only certain signals would get through when certain buttons are pressed. It's just cheaper to do it that way. Then you program the bed itself to only recognize certain signals. I'm sure if I were to, you know, cross those over and send that out that wire, that the device, the bed that this is connected to, would be like, wouldn't do anything with it. So here's the basic process I used to reverse engineer this. First, we want to get this off of here. One of the major complaints, before I get into that, the guy has is, you know, you press these buttons, especially these two, they don't work. I've gotten in here and played with the domes several times, tweaked the edges and stuff. I just can't get them to work very reliably. So that's the major complaint. And then, you know, this thing keeps breaking, and these solder joints are eventually just going to get to the point where you're going to rip a pad and they won't stay connected anymore or whatnot. So here is the reverse engineer. The first thing I did was I opened it up and I took a look at it, and luckily there are no microcontrollers on it. There's no brain box on here that's doing weird things that's picking these up and sending signals out. However, we look at the bottom and we basically have a sort of diode logic array, kind of like a poor man's ROM in a way, a poor man's encoder. And it's actually pretty genius the way they've got it set up. So, you know, I took Mr. Thing here, Mr. Meter. We take this and we try to figure out what on here comes out these pins to figure out what's going on. Now, you could go down a rabbit hole if you wanted to and take a look at this stupid thing and try to like map out all of the traces here to which these diodes go and how they all hook up. But, you know, I was looking at this, I was thinking, we only need these 5 buttons. I don't need to figure out what the rest of this stuff is, because the rest of this stuff isn't going to do anything for this bed anyway. It's only these top 5 here that are going to do anything. So that's what I decided to decode. So I went through and we took a quick look, and the first thing we can see is that the outer ring of these, this, you know, the outer gold contact on all of these is bridged together. And if you trace that down through here, and all this, it ends up coming out this far left pin. So this far left pin right here is that outer connection. See? On all of them. So I figure this is a voltage input, effectively. This has got 5 volts or 12 volts or something that's coming up through this, and then it's going to when you contact these two together, that signal is going to bridge across and then come back down and back out, you know, the connector there. So then the next thing we want to do is we got to try to figure out exactly how these signals are coming out these pins. Now, if we look at this and we think about it, we've got, basically, this is a what's called a 6-pin phone jack. I don't know what the technical term is, but we've got 6 pins here. And we only know 5 can actually be used to send a signal, because this one here is our power. So we have these 5 connections that we're trying to send 1, 2, 3, 4, 5, 6, and we need to send 12 signals out. The only way we're going to do that is with binary codes of some description, right? Because it's the only way to compress that many signals in there. A kind of, you can kind of think of it as multiplexing, but not exactly. Because if we had one wire for each one of these, which would be the simplest way logically to put it together, then I'd have to have like 13 pins down here, and then I'd have to have like a DB25 connector, and you know, they're not going to design it that way. So they designed it with diode logic. Effectively, what they have is they have 1 or more diodes connected directly to each of these pads, like this. And then those diodes, the output sides of those diodes, connect to different sets of the output pins, effectively. So it kind of in a bus arrangement. This achieves 2 things. One, it allows you to connect each of these pads to more than one of these pins simultaneously. You just connect it out to the pins that you want your binary code for, kind of like a bus arrangement. But the diodes then also prevent backfeeding, so that if you press more than one button at a time, it's not going to combine codes in theory. In theory, anyway. It's kind of just, it's like a diode ROM or diode logic, basically. So let's take a look at actually how they encode that, give you an idea of that. So I have a little whiz-bang wired up here. Basically, this is just an Ethernet connector with some stripped Ethernet wire connected and crimped down into the same pins that this presents here. And then I can put the voltage on one and send voltage up through the board. Then I can probe these and see which ones are on or off. And then that will tell us basically what codes each one of these buttons is sending out. And then we can write a table of those codes and figure out how we need to wire up our replacement. So I will demonstrate for you how that's worky. First off, I have to remember which one is which color is power. It's blue on this side, so that's the far left, which means it's blue on this side, which is going to be the far the far left as well. And the far left on this is white, orange, orange. It's going to be orange. So orange here is going to be, here, let's get one of these things. Orange is going to be our power feed, effectively. Put that on the positive connector. I'm not sure if you can see all that. So basically, following the standard Cat5 or RJ or the 568 code, it's white, orange, orange, white, green, blue, so on and so forth. You know, when we put this in, we're skipping the far left pin on this connector because we are only using 6 of them. So it's white, orange, orange. That means the blue wire here, which is our power wire here, will be the orange wire on this. Plug that in, orange wire plugged into there, connected and plugged into our meter right here. And then, in theory, when I connect this to certain wire pins, then short these out, I'm going to get certain codes. So let's get something here to do this. And so let's, this is kind of footery here to get this, but when I short this out, I should get some codes on this. Different things should conduct here, if I'm doing it correctly. Of course, I'm probably screwing it all up live on camera, but this is basically how I figured it out. Doobie doobie doo. I may also be sending voltage through this backwards because diodes. I think I might be. Hold on. Nope, that's correct. Okay. Of course it's going to fail live on camera. I had this all figured out and everything. It's going to look really smart and be like, look at how smart I am. Let's put it in diode mode. That might work better. Yeah, there we go. So I'm thinking it's running through a diode, it won't technically conduct. Yeah, that might be our problem. So let's do this. I'm really batting 1,000 here, aren't I? Yeah, there we go. Instead of doing it on this thing, which is apparently giving us a stupid... Well, I do need it to feed that in. We'll just do it down here. So yeah, basically if I push this across, I contact that, and I bridge some pins here, we can see that. If it's going to, yep, we get diode signal there, but say on this one over here, I don't get anything. How about this pin? Yep, that's got diode signal. What about that one? Nope. What about that one? Yep, actually I don't think this one's supposed to have signal. It doesn't, yeah. This one's got signal. That's got signal. So basically you can see what they're doing is they're using the diode array to light up certain pins on this data bus effectively. But only those pins, and also by using diodes preventing it from backfeeding. You can almost think of it as a keyboard matrix, but instead of being like a 1-to-1, it's a 1-to-2 or a 1-to-3 keyboard matrix that allows you to have effectively fewer pins because you're sending out a binary signal or a binary coded decimal something or other instead of just lighting up a single line and using a scan buffer or a scanning device to scan through the whole keyboard. This just lights it up, and then you can use logic to turn on a direct relay or something like that. So it's actually pretty smart the way they did that. So we are done with Mr. Thingy. It can go over here. So I'm going to show you what I figured out. Now I did do some of this by the magic of YouTube magic here. I decoded this ahead of time because I don't think decoding that live on camera is very interesting. So basically here's what we got. We've got the 5 different signals, or the 5 different commands. And then we have 6 lines, the far left one here being our power input, and then we have these outputs. And I just labeled them 43210, kind of binary. And then what I did is I went through and I mapped which one of those pins conducted based on which button was pressed. And then I created basically this kind of truth table. Once I created a truth table, then I can go ahead and write out basically a schematic. These are going to be our buttons right here. So when you press each button, it does the thing. Our power comes in. Think of this as our connector. Our power comes in and goes into the button and waits. And when you press it, it conducts. And then this shows, if this were aligned as a bus, which diodes here I would have to connect to which bus line to make that work. Now, pretty straightforward, easy to do. So what do we need to do now? Well, we need to build a new one of those. And luckily, again, by the score of YouTube magic, I did some of the work ahead of time, because getting and screwing around with these buttons was a pain in the butt. So basically, we have some buttons here and a little enclosure that we can put together. Now, I am going to have to Dremel some holes in this enclosure. And this thing's actually going to go in here this way. So the buttons, I can Dremel the holes, the buttons will show up from the bottom. But basically, we have the enclosure here. Up, down, and massage. So head up, head down, foot up, foot down, massage. And then basically, we just need to wire up a bus, bring the wires out at the bottom, get things connected, and Bob's your uncle. We can use this kind of as our reference. And I think I'll end up wiring these the same way from the viewpoint of this, the same way it is here, just to keep the logic simple for me. And then I'll figure out when we connect the wire, I'll figure that out after the fact. While we're doing this, we won't need these connector boxes. They're just going to be in the way. Soldering iron. Get that turned on and heating up. Sponge for cleaning the soldering iron. See? For once, I actually thought ahead. Okay. Let's take a look here. We have a few more people watching. Hello, how you doing? Wow, 21 minutes already. This flies. Yeah, to anybody who showed up after the fact, yeah, we're reverse engineering this thing. You can go back and watch from the beginning and play in 2x mode, and you'll eventually get caught up to us. So yeah. So here we are. What we need to do, so we need to create the concept of a 6-line bus here. Get our power routed so that basically we have a, I think I would want to do a bus up the middle with the power, bring the power in through the center, and then bring our diodes out this way into the bus lines. Maybe, I don't know, maybe I'll bring them out this way. I'm not sure exactly how I want to do that, so we'll see. With this little thing, all the soldering action takes place on that side, which is fine, because when you think about it, when this is going to have to go in there, you know, it's going to have to squeeze in. We're going to have more room on the back side for our electronicals, and these buttons will just stick out the front. So we don't want to put any electronics on this side if we can avoid it. Also, you know, it's a one-sided board. This is where all our solder points are. Anyway, so what are we going to need for this? We're going to need a buttload of diodes. Hey, look, I happen to have a buttload of diodes. As a matter of fact, I looked at them. They're exactly the same model. They're, what are they, 4148s. So, easy peasy. So let us see what we need to do. The first thing I want to do is I'm just going to solder all these connectors on, so you can see how that to be done. Now this is nice. These are nice clean copper pads. I shouldn't have to flux it or anything. I should just be able to smack them on. So let's see. If we're lucky, everything will go horribly wrong and you get to laugh at me live on camera. It'll be great. So let's get these things soldered in. Soldered in. That one's on. And this one. And this one. You can do it. You can do it. There you go. This one. Come on. You can do it. Oh, so what's up with everybody in in your world. Talk about mine a little bit. You know, I work in IT for a living. Oh, and by the way, if you can't hear me, yell at me. This camera right here is the one that's doing all of the video and stuff, or the audio. So if you can't hear me, if that's not loud enough, yell in the chat or something. I don't see anybody jumping in the chat and saying anything, but you know, let me know if you can't hear me. So yeah, I work in IT, and we've been crazy busy. And also here in the United States, we have this issue with employment, where finding really good people is very difficult. And, you know, we need multiple good IT folks for our organization. And we are just having problems finding anybody because the unemployment rate's so low. So, ostensibly, I'm supposed to be in sales. You know, I'm supposed to go out and talk to people and figure out what solutions they need for their stuff, and help them get those solutions implemented. But I've also been doing engineering work and all types of other stuff. So work has been crazy. Many times I come home at the end of the day and I don't feel like doing anything, and then you know, that means I end up not doing videos or not working on the museum, you know, not working on JCM1 or whatever, because, you know, life effectively. So I apologize, you know, if you guys have been missing me for whatever reason. I'm not sure why you would, but if you are, and where's Joe? What's he doing? I'm just really busy. That's the name of the game, basically. So let's get all of these things soldered in here. We're basically just getting the buttons soldered in. Come on, you can do it. I know you can. Clean this off a little bit. Soldering irons like to be nice and super clean. There we go. Doobie, 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 doobie. All right, just double checking. Some of these aren't that great. Need to reflow a few of them. Of course, you know, my soldering's a little sloppy. It always has been. That is who I am. I don't really worry about it. If it works and the joints don't come out, that's all that matters. Yeah. But that's the trick, making sure the joints don't come out. Yeah, that looks okay. So, let's see here. Now we got that put down, I'll put that up there. Now we got that put together. Let's do some continuity tests here to ensure that I got the buttons working proper. Oh, stop beeping. Shut up. I got the connector sensor here that detects when you've got it in amps or something, when you're in voltage mode, is like loose or something, and it beeps when you shake it. I don't know why. I have to get inside there and muck around with it. So that means we want to ensure that this gets continuity across it when I press it, right? Now across this way. Yes. Yep, this is a little footery. That one works. Come on. Trying to do a three-hand job with two hands. That one works. That one works. Am I pressing the wrong one? Is that the problem? Nope, I just didn't have it connected well. Yep, that one works. And that one works. We got good buttons on all O-dem. Okay, so what we do now, we need to figure out how we're going to wire our bus up. This is going to be interesting. First off, let's see. Let me get some wire, because I'm probably going to need some of that. And I may be able to just do the jumper pad jumpering thing, I think. Let me confirm the conductivity of these. It's top to bottom, right? Yeah, it always conducts across, but it does not conduct top to bottom. So, let's, yeah, we will bus everything together on a central bus down through here for the power. We'll start that first. That's probably the easiest thing. Now, can we do that with just soldering the stuff together? Maybe. Maybe. Doing the little solder flow trick thingy. Or you bridge pads together, basically. I don't know. Can we do that? Let's see how smart IE is. I can get those to bridge. Trying to bridge across the solder mask is a pain in the butt. Yeah. Yeah, it doesn't want to do it. So, we'll do it the way I normally do it. That's with a lot of wire. So we want to connect these two together, and these two together, and these two together, and then run a bus line down it, right? That's what we'll do. How many of these little wires will we need? 3. 1. 2. 3. Then we need to strip them. Just a tiny bit. Is this 22 gauge or 24 gauge? I think it's 22. Yep, strip just a tiny bit off. Because this the sheathing on this wire tends to shrink back a little bit when you solder it, so you don't really need a lot of you don't really need to strip a lot of the wire off. Just a little bit. Like that. Like that. Oops. Kind of came out there, didn't it? Well, let's try that again. See, it pulled the whole wire off there, the whole sheathing off there, and a little bit off there. Cool. So we take this, and in theory, I would, I would do a little. How can I put it? Pre-tinning of these wires, but it doesn't really matter because we got plenty of tin there anyway. So we'll just go ahead and get these wires melted in there real quick like. Maybe I do want to pre-tin them. I don't know. We'll see. Yeah, we'll pre-tin them. They're not behaving. They don't want to take the solder. So we pre-tin the wire. Let's see. Got this on here. A little bit there. A little bit there. Do this one. A little bit here. A little bit there. Just pre-tinning the wires tends to help things stick, because solder likes to stick to itself a lot better than it likes to stick to anything else. So if you pre-tin the wires, and when you put them together, all you gotta do is just reheat it, and it just goes flows together, and magic awesomeness occurs. So I get this in here. Oh, come on. You can do it. There we are. Working at the top. Yep. Connecting our buttons together. Still don't want to work. I'm failing, folks. Fail. I'm also probably not doing this on camera in a way you can see it, because, you know, live stream, don't do it often. Let's see here. Yep, let's put more solder on that pad. We'll just make it a huge blob. How's that sound? That should work. Let's see how this works. So we'll get this in here. Dooby-dooby-doo. There we go. That one's in there. And then we get this one connected to here. Let's see. Dooby-dooby-doo. Yeah, there we go. We'll get that pressed down into there. That's connected. One down, a couple more to go. I got the length a little better on these ones. That one's connected. Gotta do a little finagling with this one because it's a little too long. There we are. Get this one connected. Yep, that one's on there. And then we do the last one. Oh, good. Everybody says they can hear me. That's great. I apologize if I'm not paying attention to chat. I get so focused in what I'm doing. It's like, ah. Okay. So let's see. We're going to take this guy and wire that one up. That one's a little long, so we need to adjust it. Okay, there we go. Let's try. Am I going to be brave and do this one without the tweezers? Burn my fingers? There we are. There's one. You can do it. You can do it. And that still needs a little more adjustment. Now you're probably wondering, well, what's Joe going to do next as far as connecting these together? Well, I had a theory. My theory, once I get this soldered on here, is to take a single piece of bus wire and just burn through the insulation. That stuff. Yes, that. Burn through the insulation on that and connect them together, but I'm not sure that that'll work. So I might just jump a wire between one side of these and just bring them all connected together. So we'll see. Whatever ends up working. Doesn't have to be pretty. It's just got to work because it's going to be in the nice plastic box when we're done. So yeah, we were adjusting this connector here to get a better alignment, and failing at it. There we are. That's better. Now that should melt pretty easy. I think that worked. Yep, that's connected. So now those are connected effectively. Make sure none of our tops and bottoms across those are connected, because if they were, then we would have connection problems with the buttons themselves. I don't see any cross connects. We sort of got a little bit of one there, but not too bad. It's not actually connected, it's just close. Okay, so now we need to connect these down in a line, and I think this is where I'm going to do my bus trick. Basically, you connect it like this, kind of an M pattern, and then bring it down, and then kill the what is this stuff called again? The insulation. Why do I keep forgetting what the heck that's called? I have no idea. Whatever. How do I want to do that? Actually, I'm thinking, why don't we just go down the one side here? If we go down here like this and then bring it in, we want this on the right. We want that over, when we think about it, right? It's going to be like this. And this is our power connection right here. So we want this over on this side of the board instead of this side of the board. So why don't we bring it over here, Do a little 3D flip action. Means that we want to bring it down this side, right? Right! And I'm also going to do a little trick here. How many of these connections do we need? 6, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of those. So that means we want our connections 1, 2, 3, 4, 5, 6. We want them right there. Just a little visual reminder. My spatial acuity tends to be a little poor sometimes, so I forget things. Yeah, so that means power's over here. We'll even mark that as red. How about that? How's that sound? Power. So if we come down this side on the inside of the buttons, we're basically going to avoid any of the, we're going to avoid any of the other button connections. We're not going to cause solder bridges, that, the other. So we need a couple of these. Those two are connected, those two are connected. I'm actually just realizing when you think about it, this doesn't need to be connected right here because we're bridging across that button, which is already bridged across anyway. We're bridging across the button by itself. Yeah, but not, So that doesn't need to be there. Yep. Mistakes live on camera. Isn't it great? That's how you learn, though. That's, you make little screw ups and you move on from it. Isn't that what Bob Ross used to always say anyway? No mistakes, just happy little accidents. So let's get this out of there. You don't need to be there. Okay. Let's see. So we need to get this and make a little bus curve, basically, between those two. Is that wire too long? It kind of is. Kind of is. Can I reuse this one? Haha. Look at that. Like I planned it. For all you know, I did. Okay. Let's flatten this wire out a little bit. It's a little bent above. There we go. All right. Take two. Reflow that in there. Did that stick? No, of course it didn't. Of course it didn't. Ow. Too hot. Too hot. You can go in there anytime you want. Needs more skiz, I think. Let's get a little more. A little fresh solder. Never hurt nobody. I mean, unless you, like, swallow the solder and then lead poisoning, so don't do that. Yeah. That's your public announcement of the day. Don't eat solder. There we go. Okay. So that's bridged. So then we're going to add a little more solder to this one again. Wow, my iron is just, it's just being stupid today. It's not melting. Don't know what the deal is. Okay. Get that wire up on there nice and pretty like. Get that melted down in. Doesn't want to do the thing. I mean, it's, yeah, it's technically connected. I don't like that though. Let's add a buttload more. We're sorry, Master Shake, but we do not have, quote, unquote, a buttload of spare human parts. Anybody get that joke? Remember that one? Coffee. Okay, so that one's connected. So let's get the next jumper wire connected. This one's too long. We already determined, so we'll make it a little shorter. Yep. Do this. Yeah, there's this technique, this trick to being able to bridge these pads together that you see people do all the time. And I have just never been able to figure it out. I don't know if my iron's not hot enough, or my iron's just crap, or if I have crap solder. I don't think I have crap solder. I mean, I'm using Kester, Kester 6040 basically, with flux core on it. So I don't know what the deal is. There we go. Let's tin this one up as well. You guys have any tricks? You guys do any soldering like this before? Trying to bridge across pads and get that to work correctly? Just, you know, let me know. Let's see here. Little solder on that one. Little solder on that one. There we are. Solder fumes. It's a cheap high, or a cheap way to kill yourself. Anyway, so let's, yes, another official announcement. Don't breathe solder fumes either. Don't do drugs, kids. So let's get this in here. So that one arranged, needs a little more of a bend to it. Doobie doobie doo. Dancing is forbidden. Yes. Dancing is forbidden. Ugh, man, that show jumped the shark so long ago. But oh, it's just like Futurama. Those first few seasons, you know. Master Shake forbids it. Anyway. Yeah, my boss, I have a really cool boss at work. You know, most bosses are these stodgy business types. And he is, you know, business-oriented. That's his job. But he's also super cool. He said he and his son were binge-watching Futurama on Netflix a couple weeks ago. And I'm like, dude, you're the best. And then we started, like, throwing different Futurama quotes at each other. You know, like, that's Leela for you. Always changing her hair color instead of not looking into a box. And just stuff like that. Or what? Another of my favorite ones was the professor. I think that was the same episode, too. The multiple universe episode where he's like, the easy part was taking the brain out. The hard part was taking the brain out. And then maniacal laughter. Yeah. That's another show, you know, after season 5. Just, again, screw the pooch. It just jumped the shark, whatever. So there we go. We got all of those connected. So basically, it's the top row of pins across those two, and then those are all bridged together. And so then basically we've got effectively our positive bus. As you can see, it's basically this outer ring on all the buttons since they're all connected together. See ya, Toaster King! Have fun! Wish you could stay longer. I'm sorry this is taking so long, but, you know, fun stuff. So, yeah, I mean, come back later if you want and watch the rest of the stream afterwards. I mean, I'll be posting it to YouTube. It should post automatically after the fact, so you can come back and watch my shenanigans. So, we got all this here. That's all connected. And then what I wanted to do is I wanted to bring that down to this pad. This is our power pad again, remember, the left side, left side. So we do that with another little piece of jumper wire. Again, I think I'll bring it along the outside here. We just need it to do something along the lines of this, approximately. Doobie-doobie-doo. Be-doobie-doobie. Yeah, these live streams just, you know, they go so fast. You know, we're what, nearly an hour in now, and I've just barely put together one board. So, let's see here. Little tiny balls of blue tack make things like that easier solder. Yes, they do. I don't have any. I just learned that technique through osmosis, through watching other people's stuff, relatively recently, a few days ago. and I had subsequently, you know, forgot to prepare fully and learn to do that. But, you know, certain habits are what they are. They just, you get stuck in a certain way of doing it. Besides, back in the old days, we didn't have blue tack. You know, we had to solder uphills both ways in the snow and all that. But whatever. So you go in here. Oh, come on, stop it. Something like generally like that. Yep. As a matter of fact, I'll make it easier, and I'll put that actually in the hole. Which I guess I could have been doing all along, but I've just been, you know, tacking on solder and doing it that way. Yeah, let's add more solder to this joint. I tend to just slap things together very, how can I put it, haphazardly. And it tends to work, so yeah, I'm not really worried about it. Come on, you can melt. You can melt. You can melt any day now. You can do it. Go. Doobie doobie doo. Be doobie doobie. Oh man. Yeah, I'm starting to get really envious of the blue tack now because, you know, this thing is so fuzzy. Yeah. Go in there. Do it. Melt. Melt now. There we go. Okay, and then we just solder the poop out of this connection. Then we should have a bus all the way down. Solder. Lots and lots and lots of solder. Just solder the crap out of it. Not sure that's actually connecting to the wire. So we're going to lift it up out of the hole. Oh yeah, it wasn't connecting at all. Yep, so maybe that's the trick. Don't put it through. Okay. I am kind of putting it through the wrong side when you think about it. The components are supposed to sit on this side in theory and then connect on that side, but whatever. It's all good. Just make it work. There we go. Is that connected now? Yeah. So now let's test it through to make sure I've got continuity all the way down. These connections. Got it. There, 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 there. I should also have it on the opposite side, direct opposite pins, because that's the way these connect. But I shouldn't have it on the downward opposite pins, because that would be our contact pins. Or basically the pins that come live when we press the button. See, if I press it, I should have contact. Yeah. Yep. Cool. So that's good. So we have our bus. Now we have to figure out how to wire the diodes. And that's a little bit harder. I mean, it's not hard. I just got to brain my way through it a little bit. Okay, so let's get our logic diagram. I don't think I'll need wire cutters anymore, or strippers anymore, but you never know. Logic diagram, get this over here, take a look-see. So this is head up, so that we need to connect to 0 and 1, correct? You see that? Am I even in camera? No, not really. Head up, which is this one. If you look at it from this angle, head up connects to 0 and 1. So we need to create a bus connection between 0 and 1. So how do we do that? That's a little tricky. Yeah, I think I am going to want to do that with wires and run our bus up here and create wire connections across it, because I can't just like bridge diodes across each other and use the diodes as the wire connections themselves, or as the bus connections themselves, because then they'll touch each other because they're not insulated and whatnot. So we will do it that way. So that's this button. So basically on the downside of this, I've got to create a double diode connection, if that makes sense. Yep, something like that. How about can we do it on the top? Maybe? If we do it on the top, we can fold that over, that'll connect. We can do 2 diodes in a row right next to each other. Do I have room on the top for stuff like that? I'm not sure I do. No, I don't think that will work well. Maybe it will. Yeah, these are pretty small. I could do it that way. Put one there, same here. They're going to be on the bottom side. One there, there, because we need 2 diodes each. Because as you can see, we've got a pair of 1s for each one of these, so each one needs 2 diodes. Yeah, we put one on either side. Loop it down and through, bring the wire together. Effectively, that acts as our connection on the back side here, because it connects across. Each button is a bus across it, right? Yep. So the button itself will act as our bus, or at least our connection here, and then we just have to route the things through, right? Yeah, and so once I bring that and I solder it, then I can just solder jumper wires. Yeah, that'll work. You just solder jumper wires to a bus I run up through there, I think. I guess. So that means diodes work like this. So the black line is the line here. So that's the orientation of our diode, right? Right. So we want the black side away from the button. Yeah. So let's do that. So let's do the head up first. We want one here. Right? Like that. And then another one on the other side of it. Separate topic, have you had a chance to look at the Apple II's Raspberry card? I just picked one up and have not had the chance to set it up. No, I have not looked at that. Those Raspberry Pi or what is it, Raspberry Pis and things like that, they're interesting. I think that if you're into that kind of thing, they can be fun if you want to look at that. Basically, it turns the Apple II into a Linux terminal, effectively, and it just interfaces with the Apple II bus and uses the Apple II's underpinnings to control the Raspberry Pi, and that's neat. That's not exactly my cup of tea, though. It's like I can do that by just hooking a serial terminal to a Linux box. I mean, whatever. But I haven't investigated it a lot, so if you ever, if you start playing with that, who is that? That's El Grapadura. I'll just call you LG. So LG there, if you play around with that and you find anything super interesting on that, if it's like the bee's knees and you think it's super interesting, let me know. I have a Twitter thing up here somewhere. You can @ me on Twitter or whatever. And let me know. It's like, hey Joe, this thing is like super awesome, and then I'll check it out. I haven't personally been very interested in it because it's going a little bit beyond the retro electronics and retro computing stuff into I don't know how to describe it. It's not my cup of tea. So let's get this one in here. Yeah. I tend to like things that expand the natural capabilities of the machine, like, accelerator cards that just make the computer use tolerable or just interesting, like the floppy EMUs and stuff that allow us to continue to use the machine in its environment, but the only thing we're doing is replacing a basic functionality with one that's less unreliable. So like I like the VGA controller type stuff, so I can hook a modern monitor up to my computer, because we all know that the TVs and the monitors are going to die at some point. Or, you know, I like the floppy EMUs and stuff, that so you can use you know, you can use non-magnetic media, basically. Yeah. So let's get these diodes in here. I'm using the fold over trick. Some people are like, that stresses out the leads, and I'm like, whatever. You know, that's, you can do what you want to do. I'm doing what I want to do. So basically, we take the lead and we fold it over here like that, and we take this other lead and we fold it over like that, and then we can solder those guys into the button. This is where I find out my understanding of the directions that diodes work is backwards, and then they're all wrong, but I'm pretty sure I got it correct. Actually, I'm just going to do one of these right now, because the leads are in my way. So we'll get this one soldered. Come on, come on. Just doesn't want to do the thing. I need to smack it with a flux pen or something, maybe? I don't know. Get that heated up. You can do it. It's not even melting. I've got to have, like, I have to have an iron issue or something going on here. There we go. That wire's done. And then we'll heat it, the cross connect, over to the button. You can do it. Come on, there we go. So the cross connect is good. So we just test that real quick to make sure that that actually went. It did. Snip off the lead. You can do it. There we are. So now we'll do the next one. Same thing applies. Take the lead, bend it over, push it up against the button contact. Looking to use it as a storage medium for the Apple II. You know, that is something you could do. Like, I have not researched the Raspberry Pi or Raspberry Apple thing very much at all. So if that's a thing that you can do, like you can use it basically as a big server for your Apple II, that I do actually find interesting. Because that's a potential option for the super nerdies out there who want a little bit more than just like a, you know, a compact flash, a CFF8 3000 or a floppy EMU or something like that. You know, you'll get your storage server, but then you can do all the other cool fancy things. So let's get this soldered in here, if I can figure out the best way to hold the board down to do it. There we are. Get that melted onto that pad well. There we are, that's good. And then we do this one. There we are. Good connection. Test that solder joint there and there. Yep, it's good. Okay. So I also want to make sure my understanding of how diodes work is correct. It should come from here and go through there. Right? Yes. Okay. Yep, that's correct. Snip that off. Well, we got one button figured out. So let's get these other diode leads soldered in here. Okay. Diode leads. So yeah, what else is going on in Joe's Computer Museum world? Oh my gosh, I had so many things I want to do. Let's see. I actually have a list. I may have gone over it recently. Chris Torrance, I believe it was. I don't know if you follow Chris Torrance's channel. He does the Apple Assembly Lines podcast, and he's been doing some Hyperduino stuff and things like that. He's super cool guy. Big Apple II dude. He's in Colorado. He suggested when I did the bench tool review, he's like, hey, why don't we do you have a tool bag? Do a tool bag review. So I'm like, okay. So I wrote that on my list of things to do, and I'm gonna get to that eventually. If you follow me on the Facebooks or the Instagrams, you'll see that I acquired a whole bunch of computers from somebody who may be listening right now. I believe she was on there, Brittany McGannon. Yeah. Brittany sold me a buttload of old computers. The TRS-80 that I fixed up, which is right behind me here in a box. The Amiga 500 and a whole bunch of other things. I basically want to go through every single one of those and do cleanup, or a repair, review, on all of those machines. Basically, I don't want to say it doubled my collection, but it doubled the interesting part of my collection, the 8-bit stuff. I've got, you can probably see it right behind me, I've got a buttload of old Macs, kind of mid-90s Macs. Incredibly, vanilla and uninteresting, but it's these old 8-bits and like the Amiga and stuff I want to take a look at some point. Chris is the bomb. Did that compilation book. Oh yeah. He was it the Apples? Yeah. I don't remember exactly the name of the book, but it's, the Assembly Lines compendium or whatever it's called. He did the editing and put it together. He worked with Roger Wagner on that too. So go get Chris's book. It's friggin' awesome. I have a TRS-80 TRS-80. A TRS-80 Coco 3 that I purchased quite a while ago that I want to clean up and review. JCM1. JCM1, look at her in all her glory. Still works perfectly fine. It's been kicking around on my bench just underneath stuff, being knocked around. I went to do the Yule log video, which I thought would be funny. Went to do that and booted it up, turned it on, and it worked perfectly. It's just like, okay. That's the magic of wire wrap here. Wire wrap connections last forever. Garth Wilson, the 6502 guru. Yeah, he's the one who kind of put me onto wire wrap instead of using the breadboard stuff that I've been using for JCM1. But back to JCM1, yeah, I wanted to build a keyboard from scratch, which I had started working on. I have the whole thing laid out. I have the whole thing designed and wired up and everything. And I wanted to use, a microchip controller here to read data, to do all the hard, heavy lifting of the keyboard. And then throw it into buffers that JCM1 could use. But then, my brain started to melt and I gave up and I started doing other things. I'll get to that eventually, or I'll give up on that and do something else. I don't know. Anyway, back to what I was doing. Yeah, I'm getting on a tangent. So all those buttons are connected, and we're doing the diodes. So we got the diodes for this one. So let's do the diodes for this one. Let's do the diodes for all the things. Doobie doobie doo. Doo 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 doo. And there's that diode. There's diode number 1. Little 4148. One of these germanium diodes, something like that. Signal diodes, I think, is the technical term for them, but they do the thing we want them to do. Might as well go ahead and put all these diodes in the board while we're at it. Probably won't hurt. Okay, we want this one right here. Right? And this one right here. Right here, yeah. It's gonna get a little tight in here. because we're getting close to this other button, but I think I can make it work. Yep. A couple more to go. Get this one in here. This one in here. So what's, aside from my channel, which I have apparently, according to the number of people watching, I have about 5 really, really awesome fans and a whole bunch of stalkers, but that's okay. You can stalk if you want to. What are the other channels other people like? You guys watch EEV blog, I'm sure. There's one that I like to watch a lot, and basically because he likes to keep things simple. It's BigClive.com. He is absolutely funny Scottish dude. Knows just about everything. He came up in industrial controls and lighting and stuff, but so he does a lot of stuff with lights. But he also just, when he's doing his electronics and things, he explains everything he's doing as he goes, which is super helpful, of course. And he does programming and stuff too. He does microcontrollers and PICs and things like that, so it's pretty cool. I've also been watching a lot of I don't know why, car repair stuff lately. It's piqued my interest. It's similar, but it's mechanical instead of electronic, but it's basically the same gosh darn thing. Of course, your big time folks on that are going to be AVE, or AVE. What is it? Arduino versus Evil. Yeah, but everybody calls him AVE. Quinn Dunkey has a really cool thing. Blondie Hacks out there. South Main Auto channel is really neat too. Not that I'm trying to get you guys to like go away and go watch other people's stuff, but CPLD might be useful for the keyboard encoding, make things smaller. Yes, if I knew CPLD stuff and had all the equipment to do that. I'm trying to keep things, how can I put it? I'm trying to keep things a little bit simpler, more towards the 8-bit era than doing CPLD stuff. I'm trying to keep it very basic, as logic level, simple logic as possible, because that's just the way my brain works. And also this keyboard that I'm designing isn't permanent. It's more of the idea was more to be educational, to say, okay, this is how keyboards used to be designed. This is how they would do it, like the Apple II, for example, which is kind of what I'm taking how can I put it? I'm taking a lesson from. It's a simple diode matrix, diode keyboard matrix with a debounce circuit on it, and then it connects to a specialized controller that does all of the magic on the keyboard, and all it does is will flag the bus to say, hey, I've got a button in my buffer, come get it. And then when you read the chip, it pops it out, a ROM connection. But Terrible Fire is a great channel, has great open source accelerator cards. Cool. I will have to check that out. So we got all those diodes in, so now we need to solder all the things, right? So let's do these one at a time, right? Okay. Got this one here. There's that one. And this one. That looks good. I'm not going to test it because I can tell it just looks fine. Get that out of my way. You could snip them all off at the end, but it's kind of in my way at the moment. There's a little trick I use with my snips. I have them magnetized. I don't know if you could tell that, but it doesn't seem to help. Usually you'll clip them and things will fly off into wherever anyway. So I had seen that somewhere. It's like magnetize your snips so that they don't things you snip don't go off into the the corner of the shop, but it does anyway. So whatever. Okay, we got that one. It was this one, right? Yeah. So we need to get this one soldered. Well, that soldered really well. Maybe it helps to know what I'm doing, apparently. Okay, so that one's done. Let's do this one next, because we're on this side. Okay. Get this pad done. Oh, didn't quite get it. More solder is required. There we go. Then we will do this lead. There we are. That one's good. And then we got to do this one. So yeah, a little bit about this this client here. While I'll talk while I'm working. He's an older gentleman. He owns a Craftmatic 2 adjustable bed, because one does. And he's brought this remote in several times. I may have already talked about this before, but he's brought this remote into our shop several times because, you know, real electronic shops don't exist anymore. So he brings it to the computer shop this one time. Because we, even though we do like managed IT services and people pay us to manage their networks, we do computer repair stuff there too. And he's like, help me, Obi-Wan Kenobi, you're my only hope. I can't get a replacement remote. I think if he were to contact Craftmatic, since they still make the flipping things, he'd probably be able to get one. But he's like, can you fix this? And last time all it was this connector was busted, and we're like, okay, we cut one off there, and we use, use a crimp tool like that. You put a new one on it, and whatever. And this time he brought it in, and not only was the connector busted on it this time, but the solder joints were bad too. And so we keep fixing it. And so he brings it in a third time, and it's like, whatever. This is the first time I've ever looked at this thing. One of my technicians has looked at it multiple times. But it's gotten to the point to where he's like, we need to find a permanent solution for this guy. He doesn't want to buy a new remote. Maybe they charge him $200 for it. I don't know. I don't see how it could be that expensive. Our fee to do this is going to be somewhere around $50 or $60, right? Mainly because this is just fun for me. It's not like I'm charging him to charge him money. I'm just goofing off here. But anyway, so he wants us to figure out a solution, whatever. So the boss comes up to me. He's like, hey Joe, I see your YouTube videos. I follow you on Facebook. I see you're really handy with electronic stuff. You want a challenge? I'm like, okay, maybe. What do I need to do? And he hands me this remote. He hands me this thing. He's like, can you fix that? And I look at it. I'm like, yeah, sure, why not? So I take it apart just to make sure there's no funky microcontrollers in it with wacky code that I'd have to try to reverse engineer, because that would take, that would take me a month. And I'm like, it's just simple diode array. I'm like, yeah, sure, why not? And so I start playing around with it, and it's like, oh yeah, well this is dead simple. There's nothing to this at all. You could call it diode logic. You could call it many different things. I don't know what you want to call it exactly. It's really just a more complex version of that keyboard that I put together. Instead of having a single pin output, it's got a multiple pin output. So I did some playing around and research, and I'm like, how can we make a new remote for this guy? Instead of repairing this thing, we'll just make a new remote. And that's what we doing. Get that in there. Yep, that's good. Okay. Let's do this one next. Down the bottom side where there's more solder to connect to. Like that. Get this soldered in here. Oh, 6 people watching. A couple people joined. Hi, everybody. Welcome to the live stream. I have reversed engineered the remote to a Craftmatic Model 2 bed that we're going to be building a replacement for. Pretty nifty. If you want to go back and see some of the reverse engineering process, just go back to the beginning, start at the beginning, and then play it at double speed, and you'll end up getting caught up. Who else do I like to watch? I like to watch on YouTube, you know, the typical gamer stuff. That's really how I started watching YouTube. I had some, how can I put it? I was basically depressed. I had some clinical depression going on, and then, you know, I just kind of did nothing for a while. And I found some people on YouTube. The first big person that I found on YouTube, you probably know his name. His name is Markiplier. And I found his stuff to be funny. And he was a fellow Ohioan. And I just, for some reason, that clicked with me. And then you know, after watching his stuff, I started seeing everybody else's, all the other gamer stuff. And then I was like, wow, YouTube is basically cat videos, stupid music videos, top 10s, and a whole bunch of gamers. So I just watched a lot of that stuff to begin with for the longest time. You know, Markiplier and Jacksepticeye are probably my two favorite gamers. I watch Catherine of Sky a little bit, Quill18 a little bit, and Inter Elysium's fun. I don't watch them religiously, though. Usually I'm only watching their stuff when they've got a game that I like to watch, because I don't play games. I like to watch other people play them. I'm weird that way. I liked that for years, even, you know, 20 years ago. I enjoyed sitting in the room watching somebody else play Zelda. It's just how I am. But they got to be playing a game that I find interesting. A lot of those YouTubers, you know, Jack and Mark, you know, PewDiePie and all those, they've been playing really crappy, stupid little one-off dumb games, and I haven't really liked it. But I'll still watch their stuff from time to time. Catherine the Sky's been doing Mashinki, and gosh, what's the other thing she's been doing lately? She's been doing a lot of Factorio stuff. Oh, Factorio. Oh, yeah. Lately. That's been interesting. So I've been watching their stuff quite a bit. Who's the other engine guy? Musty1 is another guy. He takes apart small engines. He goes out to like yard sales and finds old busted up scooters and tractors and mowers and stuff like that, and systematically fixes them up and then sells them on. Pretty interesting stuff there. Again, I don't know why the small engine repair or the vehicle repair things have been a big thing for me lately, but it's just been what I've been interested in. Okay. Yeah. If it's an older gentleman, he may be nervous that a replacement from the company might be more complicated updated model of the remote. Well, I mean, it can't get much more simple than that. I mean, it's pretty straightforward remote. In order for it to be compatible, it can't really be much more complicated, but, you know, who knows. Yep, which one we want to do next? Oh, I don't know. Let's do this one, sure. Why not? Yep. Get this one in here. I'm going to preload that with a little bit. You're not supposed to preload the iron with solder, but under certain circumstances I find it helps. You're not supposed to put the solder on the iron and then carry it over. Because then what happens is the stuff you're trying to solder to isn't heated up, so it doesn't stick. But sometimes I find that putting a little bit of solder on the iron, just a little bit, not, you know, not the standard, you know, silver thin film, but just a little, like a little ball like that, helps with thermal transfer, and it helps that first contact with the pad heat up and connect. Get those out of the way. Do this one. If I can. Let's see here. See, like, I've got good connection with that pad and with the lead, but it just didn't want to do it because I had curled it up away from where I had the solder on there. That one's done. Let's do this one. Did I do that correct? Yeah, that's fine. Okay, I thought I'd done one backwards somehow. Actually, let's keep that away from the red wire. Let's run that along the bottom side. Yeah, we'll do that. This one's going to be a little tricky because it's close to my bus wire. Can I move my bus wire out of the way any at all? Maybe. Just kind of give me a little more breathing room. I don't want to melt that wire. Get that excess off there. The old decrotted stuff. Hit that pad. Hit that there. Good. Good. That worked. Hit that up a little bit. Doobie doobie doo. Be doobie 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 doo. All right, so let's get this lead done. Oh, yeah, I have a tool bag in my car because basically, where I work, we go out and we do lots of I don't want to say lots, but we do enough like wiring and network jobs and phone system setups and stuff that we have, networking tool bags, and we got 3 of those at the shop. And I would just grab those bags to go on jobs, and I'd find that, I don't know how to put it. Some of the more undisciplined folks in the shop would go and they would use tools out of a bag and then put them back in a drawer instead of putting them back in the flipping bag. And I would go on an appointment. I would grab a job. I'd grab a bag real quick, and in my infinite lack of wisdom, I wouldn't check to see what was in the bag, and they would have crap missing. And I would get like 45 minutes away and have to like fabric cobble some sort of solution to something because I didn't have stuff in my bag, and I was getting tired of it. So, and also, if I wanted to do my own stuff for family members or for neighbors or stuff, I got to borrow the shop's tools to do things. So I built my own network bag, basically, that has all the stuff in it that I know I will need to do whatever I need, wherever I might be. And it's a typical network bag, but it has a few construction-y items in it, too, because you never know exactly what you're going to run into. So, it's got your standard, it's got like crimp tools, and it's got wire cutters and things, and screwdrivers and all types of things like that. But I also have all the different types of termination connectors for coax, for Ethernet, for phone, spare bits of connector wire, pliers and tape, and blah, 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 blah. A label maker, a pair of scissors, just all types of stuff in there, so that when when I'm mobile and I need something, all I can do is reach in the bag and I got it. But of course, in my own infinite lack of wisdom again, I went to a network job a couple days ago and found that part of the toolkit was missing. I have a plastic bin. It's something. It's kind of similar to one of these things. I've got a plastic bin in there that has like drywall screws and rack nuts and cage nuts and stuff like that in it. And I found that the bag was missing. So apparently the last job I went to, I left it somewhere. Because, yeah, yep. So I just have to remember where I went to last and call up those nice people and be hey, by the way, did you happen to notice a little plastic container with a whole bunch of weird, nerdy, technical stuff in it? Because if you did, yeah, let me know. I need to come back and get that. We're down to our last diode. Yes. I was trying to, where was I yesterday? Yeah, I was in a little town. They called me out to, we just do break fix for this one client. They called me out because they were getting their room painted where their server was. And they're like, well, can't we just unplug the server and move it? I'm like, yeah, you could. Do you need to like be working tomorrow? Yeah. Is the room going to be painted and done by tomorrow? No. Well, if you unplug the server, none of your software is going to work. You realize that, right? Oh, really? So I had to come out and like wire up the server so it was in the middle of the room, but all the cables were out of the way so they could paint the room. Something like that. But yeah. So anyway, I went there, and part of that process, I was going to clean up all the stuff underneath the desk and make it all pretty. They had a little 5-port switch in that room to connect, the things in that room together. Really, they need more cables in the rooms because you shouldn't have all these little switches laying around, but whatever. They have this little 5-port switch in the room, and I was going to screw the switch up underneath the desk to get it out of the way, and I go to look for my screws, and my screws are gone. Great, awesome. So I think I just ended up just laying it down there somewhere on the floor, but stuff happens like that all the time. You just gotta deal. Okay. Come on. You can do it. There is the diode. We've been streaming for an hour and a half. We're not even halfway done yet. This is going to be a long one, folks. So there we go. We got our pair of diodes in and connected for every single one of those buttons. So what do we do next? We need to decode this sucker. Basically, we've got our left hand. We got, hey, it's red. You can see it. We got that connected, and now we've got to figure out, based on this encoding here, how to take the leads off of every one of our diodes and hook them up to the bus correctly. So, how do I want to do that? I think I'm going to do it super quick and dirty. I think what I'm going to do is I'm going to cheat and use some of the little diode lines here to convert each one of these rows into a nice solid bus, right? And then I'm going to use, if I can see it up here, yep, there it is. Maybe not that one, because I don't think I have enough for that. But I'm going to use a super fine wire like this, because it's not going to be carrying a lot of current or anything. Wire like this to just snake my connections down onto the bus lines. Something to that effect. I might not even do that, honestly. I might just tap them all together down at the bottom. That'd probably be easier. So yeah, set that up there. Get that out of the way and that out of the way. Okay. Get this off of here. Now I have to remember that this is backwards. Like this. So I'm going to have to be doing a lot of... Stop doing the thing you do. I'm going to have to be doing a lot of flipping back and forth here to get that done, but that's okay. Okay. So, this is the head up. How do you work? You need these bottom wires need to come over and connect there. So that's going to be this one here and this one here need to go where they go. One of them goes to 0 and one of them goes to 1. So it's, you have to think of it backwards. It's backwards from this. So it's 0, 1, 2, 3, 4. As a matter of fact, we might just put a 0 over here, like this. So we remember it, and we'll put 4 on this side. Yep, that'll help us remember it. Okay, so let us pre-solder this, or pre-tin it. Where's my tin? There it is. I'm going to pre-tin these lines at the bottom, right down here, and then basically we'll cut off our little wire wrap jumps from here down to there, and just tap them into the big blob of solder that's there, and it should work just fine. Yeah, let's do that. So let's blob the heck out of that with solder and make a little solder connection. And then this one. And then this one. You can do it. This one. And add a little more to this one. And this one. And this one. Come on. You can. I want a blob. Give me the blob. There we go. Nice little blobs all across there. So let's count these. There are 6 pins. So it is 1, 2, 3, 4, 5, 6, which backwards are this way. Yep. It's this way. Oh, that's hot. Jesus. Sorry. Which would be like this. Yep. So it's 4, 3, 2, 1, and 0. 0 is that side. Good. That will help me do my counting magics. You come back over here. Right there. Okay. So, let's get some wire. What's going to be the easiest wire to get off here? Probably the one I used the least of last time I was doing wiring on JCM1, which is probably brown. But you guys can't see brown, so you can't really see what I'm doing. So we're going to see if I can unravel this flippin' mess. Over here. I have no idea. There we go. That's working better. A little better. And I don't want to use red because that's our power. So, and I don't have much yellow because I use that for massive bus connection on all types of projects. So I'm running short on yellow, so I don't know. We'll use green. Green will be pretty easy to see, right? And I got a lot of it, so we'll use green. All right, so it's this one here, which is this one. So we need to connect this guy to 0. So let's do that. Figure out our line length, give a little extra for the magics. And we will trim a little bit of this off. Right here. 24 gauge. Technically this is 30 gauge, but I found this thing actually works pretty well for stripping 24 gauge wire. Or 30 gauge wire. Yep, works perfectly. Just have to turn it a little, pops it right off. Right off the end. I don't know if you can see that, but yep. And we saw our little bit of leaded love. Nice, or as Big Clive says, nice, juicy lead-based solder, because silver-based solder, that lead-free stuff, is an absolute pain to work with when you're doing hobbyist stuff like this. It's just a nightmare. So we'll do a little bit on that one, and a little bit on this one. I don't think that this one took any, but whatever. Okay. Okay, so the first one is 0. So that is going to be our diode here. It's going to be the bottom side of that diode, which is right here. Yep, I managed to move all the solder off the joint completely and not even solder the wire in. So that's there. This comes into a 0 right here. Just a quick little love tap. Yep, that's 0. Matter of fact, I might use a different color for each one of these. How's that sound? And then the next one is going to be 1. So that's going to be this connection right here. This one, right? Flip that over. It's this one right here. So this one goes down to 1. See if we can get this wire a little bit tighter. That previous one was a little loose. And we don't want these, you know, flopping around or they're going to cause issues. Doobie doobie doo, be doobie doobie. Some of you might be wondering why I'm doing electronics instead of computers today. Well, because I thought it would be fun to share this with you. I'm not only into computers, I'm also into electronics. When you start, you know, when it's newer computers and stuff, electronics aren't really part of the thing because, you know, everything is so highly integrated and super complicated that, you know, some new, you know, Ryzen-based machine, you know, you're not going to be getting in there soldering stuff to it. You don't really need to know the electronicals, as Abe says, to do that. But these older computers, if you're getting into repairing the older PCs, or like, you know, with JCM1, if you're building one from scratch, you kind of need to know about electronics. So I started teaching myself electronics. I was super interested in electronics when I was a little kid. Like, you know, 10 or so. But I never really focused on it enough. And then, you know, my interest changed to computers, and the computers part stuck. And hence the reason why I am a computer guy by trade. But, you know, the electronics were always fascinating to me. So I when I started getting back into the 8-bit computer stuff and doing all that. So that's 0, that's 1, 0 and 1, 0 and 1, yes. I started getting back into all that stuff. You know, it's like, well, I'm going to have to learn how to do this. And when you're starting to get into, you know, when you saw the work I had to do with the TRS-80 and all the other stuff, knowing your electronics really helps. It helps you know how to troubleshoot things and this, that, the other. So let's get these wires out of the way here. There we go. Yeah, we'll fiddle with it later. So let's use a little green pen to note that we have that one done and that one done. So now we're on to the next set. And to help us not get confused, put that right over that. Okay. What's next? We need head down. That's this one right here, which is going to be that connection and that connection. So those are 1 and 2, which would be 1 and 2. So what color we want to use for head down? Purple, blue, chartreuse. Well, I like blue, so we're going to use blue for this one because that side's purple or green. Green and blue go together, sort of, kind of. Some people say, don't wear green with blue. I think green and blue together looks great. So yeah, so let's do the outside one like we did before. And so that's going to go to 1. So that's this one here, right? Yep. You go to 1. And we'll do it something like that. Okay. Strip de wire. Just a little bit off the top. Okay. Stop it! The connection thing. Maybe if we have time after this. I don't know. We're going on we're getting hour and 42 minutes here. Maybe at some point, if we got time, I'll take this apart on there too, you know. The guy who helped design this, you know, Dave Jones, the EV blog, don't turn it on, take it apart. We might just do that. Figure out what's wrong with that sensor in there for that connector. So solder this wire a little bit, just a little bit, do it. And this one, a little bit. There we are. Okay. So head down, that's this one here. Ow, don't touch your skin with a soldering iron. That hurt. I'm a clumsy guy. So, trying to get this stable so it doesn't flop around when I do that. That's in there. And you go to 1, which is this one. Right here, the same one with the green one in it. Trick is just getting this soldered down and holding the green one in place as well so it doesn't pop out. I think that'll do it. Yep. I don't know, I should probably test the continuity of that, right? Maybe. Let's see. Yep. We got that. Stop it! Beep, 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 beep. So, does this have contact to that one? Does this have contact to 1? Yes. Do you have contact to 1? Yep. Okay. The next one is, we got this one done. The next one is number 2. Who does number 2 walk for? Yep. So you go to number 2, so you're going to come from here and go to there. We'll cut it right about there. Little wire wrap wire. Wire wrap wire is so handy for so many things. You know, like the 650 Doodad. On the front, it looks so awesome. On the back, it's just a mess of wire wrap wires. And now it's going to be a pain in the butt to hang back up. Hold on. There we go. Yes, we're doing this. Got ahead of myself. I need to strip the wires off, or strip the sheath off first. Just a little bit there, and a little bit here. Okay. Do-da-ting, where's my lead? Come here, lead. You and I need to get involved. Yeah, interesting little thing. I just remembered. I took Latin in high school, which I found absolutely phenomenal. Found it very interesting. The reason I was able to take Latin is because our little school here that I went to has one of the top Latin teachers in the United States. Her name is Mary Jo Berensmeyer. Go look her up. She is an absolute goddess. Wonderful Catholic lady. Knows Latin inside it. She is like the best. She's awesome. She was really good at teaching you how to learn Latin. And when we started the unit on prepositions describe the relation between, it's a word, a joiner that describes the relation between one object and another object. So, you know, this hand is above that hand, you know, above, beyond, beside, by, through, about, stuff like that. And she starts the unit by walking up to the front of the class. She liked to use overhead projectors. She walks up to the front of the class, starts fondling the head of the overhead projector. I kid you fricking not. In high school. And very salaciously says, I have a relationship with this overhead. And we're all like, what the? But I guarantee you, because of that, I always know from now on what a preposition means. And just dealing with the solder there made me think of relationships and prepositions. Okay. So we need this one right here, right? Yep. Let's get this one in here. Took 3 years of Latin. Forgotten most of it. But I tell you what, that was one of the coolest classes I ever had. Is this iron not functioning? It's not melting anything. Melt. Flow. The spice must flow. There we go. Okay, that's good. And so this one goes to 2. 0, 1, 2. It's this one here. One next door. There we go. 8 people watching. Wow. Cool, it's jumped up. Again, anybody who's come on recently, welcome. Hello, Joe's Computer Museum. You've probably watched my videos before. We have reverse engineered the remote to a Craftmatic 2 model bed, Craftmatic 2 model adjustable bed, because a client needed a replacement remote. I've already done all the reverse engineering. If you want to catch up, go back to the beginning of the stream, watch the reverse engineering, and play it at 2 times speed, and you'll get caught up to where we are. So that one is done. We got that one connected. Yes. So both of these buttons are done, in theory. So now we need to do those 2 buttons. So let's mark this one as done. And cover up those so I don't get confused. I'll do it this way. So we need foot up, which is this one, which is 3 and 4. These codes tend to not overlap too much on this, so it makes it kind of easy. So these are what? 3 and 4. 3 and 4. 3 and 4. So what color do we want to use? We used blue, green. Let's use purple. Purple! Hello, purple. Where is purple? Purple is my friend. We get along swimmingly. Where in the world? Okay, here we are. So purple, or foot up, is 3. So let's connect. We'll follow the same pattern. We'll do the outer ones. This is foot up. That means our diode connections are going to be right here and right here. Again, let me double check, make sure I connected them to the bottom. Yeah, diode connections. So it'll go through the switch and through the diode. Yep, so it's going to be this one and this one. So we'll start with this. Connect it, all right, yeah. And it's going to go to 3, which is this one. Something close to that. Okay. Strip the wire. Rinse, repeat. Adjustments wrong. Hold on. There we go. Strip the wire. Strip the wire. Tin the wire. I should get a soldering station at some point. I just been using this little 18 watt Weller for the longest time because it works. It was cheap. It was available at the local hardware store when I needed a soldering iron. This was younger me before I figured out how to look things up on the internet, and it just works. It does what I need it to do, and because it continues to work, I've seen no reason yet to replace it. But it is what it is. So again, we want 3, so let's get this wire hooked up. Goes right on this one here. Come on now. Yeah, right here, 3. Man, my fingers are skittery, jittery. Too much coffee. There we go. That one's on there. Ooh, I moved it too soon. No, I let go too soon. The solder flipped about. Let's try that again. There we go. It's solidified. Okay. So that one goes there, and you go to 3, which is 0, 1, 2, 3, this one right here. Which is that one right there. Solder you on, reflow, and done. And I'm actually going to add a little bit more that does not have enough of a blob on it for my taste. Okay. Blob. Blah, blah. There we go. In retrospect, I probably should have terminated those up here instead of down here to make it a little easier to get my wires. Because basically, you know, I need to connect this somehow, and I was just going to solder it directly to the board and then use zip ties as cable relief or something to make it easier to get those wires through there. But, you know, whatever. It is what it is now. I'm not going to undo it all. So that's number 3. Okay, and now we need to do number 4. Hello, purple. Purple. Give us a word that ends in purple. Or ends in erple. Yes? Like erple. No. That is incorrect. You go to 4, which is approximately right there. So that's plenty long enough for that job. Alright, strip it off. Got to be careful about saying the word strip it. Google's automatic content filtering might flag this and say, "Hey, you said something nasty, you're demonetized, nah." Jerks. No, but seriously though. Yeah, people getting whole videos demonetized because they dropped one F-bomb, like accidentally. And just, yeah. Not that monetization is working for me yet, because I haven't met the hours threshold. So, if you really like my channel, but you haven't watched all my videos, go back and watch them again. And again. And again. And help me get my monetization. So that I can start doing even cooler stuff. I'm about 50% of the way I need to be there. YouTube requires you to have 4,000 hours in the past 12 months. And I'm at like 2,200 hours this year. So, yeah. Let's go ahead and do this thing. We'll get this one wired up to this here. Melt the solder. That's connected. And you go to 4. Cuatro, the last one right here. Again, let me check this, make sure I'm doing that correctly. Yes, I am. Okay. That would suck if I got this all done and had it all backwards. So we just melt that solder in. There it is. That one's done. Now we have to do foot down, which is going to be, foot down is 2 and 3. What color for foot down? Oh, I don't know. We did purple, red, I don't know, yellow. I don't have a lot of yellow left on this spool, but we'll use it anyway. Why not? Foot down is this button here, which is going to be these ones here, which would be this one. It's going to be that connection and this connection. So this stuff is in the way a little bit. Let's just get it just out of the way. Okay, so we need to go to 2 and 3, which is 0, 1, 2, and 3. These two here. Okay, I'm actually going to go through these real quick and double check, make sure I got these correct before I do this. So head up is 0 and 1. Head up is green, so it's 0 and 1. Yes. Head down is 1 and 2. Head down is blue. 0, 1 and 2. Yes. Foot up is 3 and 4. Foot up is purple. That is 0, 1, 2, 3, and 4. Yes. Okay. Just making sure I got this correct. Again, don't want to get all the way through that and have that all confuse-a-bobbered. Foot down. So 2 and 3. That again is this one here. You have to go from here, 0, 1, 2, to approximately there. Wires cut. See that? See, it didn't beep that time. It just like reset. Need to call up Dave Jones and be like, "Hey, my meter's broke. Send me a new one. And he'll be like, fix your own damn meter. Oops, I said a curse word. Demonetized. Okay. Alright. It's probably just a bad solder joint in there. That'd be my guess. Okay. Anything in the chat? Nothing in the chat. People are pretty quiet. Ooh, 9 people watching. Wow. About 2 hours in. All the few people who have come in the past few minutes. Again, I'm reverse engineering the remote to a Craftmatic Model 2 adjustable bed. We already did the reverse engineering of the diode logic they used to select the lines on here, and that is what this diagram is over here. I'm using it to get a replacement wired up. So if you want to go back and see all that, just go back to the beginning, play from the beginning, put it on 2 times speed, and you'll get caught up. So what am I doing? Yes, we are soldering this wire right here, and this one right here. That's good. And again, that's this one here. So let's get this one soldered in. I moved it before it was solid. There we go. And again, this is foot down, so it's going to 2. So that's 0, 1, 2. That's this one right here. U right there. And is that soldered in place? Yep, it's good. Now we need to do the next one. Let's mark that as done so I don't do it twice accidentally. Next one is 3. So we need to come from here, approximately, to 3, 0, 0, 1, 2, 3. So about there. That works for me. Strip the wire. Right there. Again, all the people who've come on recently, I mentioned it at the beginning, but I haven't mentioned it in a little bit of a while. I have a Twitter page, Twitter account. Sorry, I'm an old 80s guy. I name things wrong all the time. Like, I'm on the Facebook and the Twitter. And that's where I announce just little things I'm doing. You know, little cool funny things. Like earlier I posted a thing about when I was out to lunch, lady who served us, her name in their point of sale system was Heather282 or something like that. It made her look like a robot, which was silly. But also, you know, posting about when live streams are going to happen, when my new videos are up, and all of that stuff. You can follow me on there. I also have a Patreon where you can donate anywhere between $1 or $1 million, however much you want to do. And that helps me do my endeavors, you know, this stuff helps me buy little bits and pieces for doing things like this. So now, let's see here. 3 foot down is 3. So our other connection goes right here. Let's turn it this way. It'll probably work better. Yep, I like that. That's connected. Yep. And you go to 3, right? 0, 1, 2, 3. We're doing 2 and 3, right? We did 2. 0, 1, 2. Yep, that's the one right next to it. Okay. 2, 3. This one with the purple one. Right? Oh, come on. Again, I'm really liking that blue tack idea. I wish I had some, but I don't. Not sure I have anything like it either. Get that melted in. Oh, I totally screwed that up. Oh no, I got it. Ow! Hot. Yep, that's good. So it means we got that one. Foot down is done. And the last one we need to do is the massage button. Ooh, massage. And that's 0 and 3. Why? I don't know. That's how they did it. What do we want to do for a massage? What color do we have left? Black is ground, and I don't like the idea of ground, although technically those are kind of acting as grounds for the circuit. So let's use orange. Let's use orange. Brown will be hard to see on that, so it'll be hard for you to see what I'm doing. Orange, how does orange look? Can you see that? Yeah, well enough. Let's see. So, massage button is the last button down here. So it's these two connectors, there and there. So this one goes to 0, which is straight down. That's a short little hop. Not very long at all. It's about that long. Good job. Strip the wire, solder the wire, connect the wire. Same thing we've done 20 times before. Or 10 times before. 5 buttons, 8 times, whatever. I can't math. I'm bad at math. I'm just horrible. Calculate. Did you see that? Did you see that thing? Stop it! Just off. Shut up. Put this in here. 2 hours and 5 minutes, man. Crazy. Let's put this on here. Solder that on. And solder this on there. Okay, always tin your leads. And then we have to do this one. This one's 0. I'm doing it backwards just because this one's easier to get to. I've been doing the left side than the right side, or the outside and the inside. But they're both out. It doesn't matter. 0. Yep. Maybe slightly 2 because that one's close. Get this soldered in. Get it pressed down there. Melt solder. That's going to hurt. It's going to get hot. Ow. Okay. Undone. Get this joined up to 0. Can we? Is it going to happen? Uh-huh. 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 Just like that. This is also going to be hot and hurt, but I'll live. I do not like that. It does not have a good connection. So let's do that again. There we go. That's sunk in. Ow! No pain, no gain, right? So that one is in 0. So that's here. This one. So we got that one. Now we need to do 3. Okay. 3. So that's this one here. And it goes to 0, 1, 2, 3. The one with the purple and yellow on it. So we'll cut it off right about here. Lather, rinse, repeat. Strip. Tin. The sponge is getting a little dry. Tin. And we should be done with the wire wrap wire. We should be completely done with that. So I'm going to clean that up now. Just get it out of my way. I find if you leave it laying around, it likes to get caught and tangled in flipping everything. All the time. Forever. You go to walk and you'll like walk through it and you'll trip and you'll yank stuff off your desk and then it goes rolling across the floor and it unspools. You know, that I can't confirm or deny that has actually happened. It has happened. Cool. We are done with that. Okay. Get this Y in here. You are number 3. You go right here. Melt that in. And then 3. It is 0, 1, 2, 3. I should have just named them 1, 2, 3, 4. It would have been easier to count, but I wanted to label them in binary. I don't know why. Just how I wanted to do it. It felt more correct somehow. And there we are. So in theory, that is a replacement for that. It should just work. Clean up some of these wires a little bit, just make it pretty, because why not? Pretty it up. Just realizing you can't see what I'm doing here. Yep. Cool. So in theory, let's see if we can figure out a way to test this visually. That is, yes. Yes, that's the power line. Okay. So, let's see if we can do some clip lead magic here and test this out. So positive, red. Is this. Here, let's use a red one. Yeah. That way it'll be color coordinated or something. And that goes on the red one all the way on this side. We'll just clip that guy right on there. Because why not? Because that will work just fine. So in theory, when we turn this on to diode, right, and I check all these, I should get nothing on any of these. Nothing at all. But when I press them, I should get the same codes that we have up here, right? So let's test the theory. We'll press this down. As a matter of fact, do I have a way to press that down easy? Hold on. I'm going to go off camera for a second. How about this? Yes. Will you press my button down? Push my buttons. There we go. That makes it easy. So that's pressed down. So if you look at this from the back, and we should have 0 and 1. 0. Yep. 1. Yep. 2. No. 3. No. 4. No. Haha. Let's head up. Good. Head down. Let's get this on here in a way that's not going to destroy the button. It wants to try to destroy the button here. I don't know why. We definitely don't want to break this button because then I have to take it out and resolder it. There we go. All right, head down. Head down should be 0, correct. 1, yes. Can you see that? Yeah, here, let's bring that back in a little bit easier for you. Can you read it that way? Yep. So we have, it should be 0, 1, 1, 0, 0. We have 0, 1, 1, 0, 0. Bingo. That one's good. Foot up. It's this one here. Foot up is 0, 0, 0, 1, 1. 0, 0, 0, 1, 1. Works. Foot down. 0, 0, 1, 1, 0. 0, 0, 1, 1. Oops. Start over. 0, 0, 1, 1, 0. Ha-ha! And massage, the final button, the magical massage button. That's pressed. And it's 1, 0, 0, 1, 0. 1, 0, 0, 1, 0. 1, 0, 0. I soldered it in the wrong place. Or I have a back trace going through something. I might need to add an extra diode. Let me take a look. So that is an issue. So massage is orange. How are you getting through? Was I pressing that button down? I'll bet you I was just pressing the button down. Yeah, because they have the same code overlaid. It's an and. Yep, that's what it was. I was just pressing that button down. So let's just hold the button down with our finger. Right there. So we have 1, 0, 0. There we go. 1, 1. Yes. 0. Ha-ha! Success! Great. That's freaking awesome. Nothing quite like doing a job like that and getting it right pretty much the first time, bang on. Wow! Okay. So we have successfully and properly reverse engineered that in a functional manner. Now what's going to happen is, and from what I can tell from this, is that the same thing would happen with this. If you press more than one button, you're going to get an overlay of codes. But I don't think they're going to do anything, because those overlay of codes are codes that don't match anything the machine's going to know how to do anyway. So it probably will just ignore those codes. And I'm not too worried about it. We shouldn't have any over voltages or anything, because it's just a simple, it's like a 3.3 volt or 5 volt logic circuit or something to that effect. It's not a high speed bus. I seriously doubt they're going to be punching like 24 volts through this. Even if they were, it'd probably be fine. It's less the voltage we're worried about and more the current. And yeah, any current they're pushing through this is milliamps. They're not going to be pushing like buttloads of current through it. So I'm not really worried about that. In addition, these push buttons should be a lot more reliable than these tactile domes. These are technically tactile dome buttons too, but they're recessed in there, and it's going to make it to where, you know, the mechanicals are gonna work a lot better over a longer period of time. So, what's next with this little project? Well, let's see. Well, we want to try to get it into the box, right? So it's basically, it's going to sit in here like this, and this is going to go over to, actually, it's going to, I take that back. It's going to sit in here like, no, it has to sit in there like that. I got it backwards or something. Hold on. No, it's going to sit in here like this, right? And then I'm going to cut holes in the top here. And then I'm going to, instead of fixing it to the bottom with the screws here, I'm going to affix it to the top. It's going to go in the top like this, and then they'll come up through there, and then we screw it together. So let's see if I can figure that out. This is where it gets boring a little bit, because I'm just going to be doing hobby work, effectively. So I thought a little bit about how I wanted to do this and how these buttons are shaped and formed, and I figure if I go up through the board with a pin like this and like score the back of this, I can figure out where I need to cut my holes. And then I can drill little pilot holes, and then probably, I don't know, cut it from the top. I'm not sure if cutting it from the top or the bottom is going to have the better result. I don't know. I'm also thinking that maybe what I'll do, that'll probably look better. Yeah. Yeah. Here's what I'll do. I'll put it in there. I'll figure out where my holes are, right? Because I can do this upside down like that because that's the way it's going to be. So that's fine. I wouldn't want to put it in this way and do it, although I could, because as you see, I thought ahead. I designed that symmetrically, so this, or at least this direction anyway. Horizontally, it's the same, so it doesn't matter where I put it. But I could use a fat drill bit, which, hey, look, YouTube magic. I have drill bits. And basically, what I would do is find my corners, score a little line across it, to find the middle point of the button, and then just like drill a nice round hole. It wouldn't completely clear the button, but it'd get pretty close, and then I can use a knife to just score out the corners to get it in there. I think that will be what we want to do. Yeah. Because it's probably, yeah, yep, we'll do that. I'll put a pilot hole this way for all the buttons, then I'll drill it from this side, and that will likely give us a cleaner hole. So let's do that. So basically, I want to screw this in first so that it doesn't move around on me and I don't have holes in all types of weird places. Screwdriver. Only barely magnetic screwdriver. You go in here, and you go in here. And again, make sure that's the top. Yes, okay. We wouldn't want to put holes in the bottom of it. That would be dumb. And that's also the wrong hole. There we go. You go in here like this, figure out how we want to journal that, and just get it in there in a nice fashion. And it doesn't have a lot of play, only a few thou, so that's good. That one's in there. This one is in here. And this one is in here. I'm glad you guys are able to hear me. I turned the heat off. And it's a relatively warm day. It's like 40 or 50 degrees outside, so I'm able to do that. Because you can, I don't know if you've been able to see in some of my other camera shots. You can't see it in that shot, but if I switch to this one, you can see it right back here is the furnace. And when you know, the furnace is on, you can't hear me. So I turn that off. That's in there nice and snug. Cool. Okay, so let's figure out where these are gonna go. We're gonna put this in there and score a little bit. And there, and score a little bit. And same for this one. Do it for all of them. I'm just a paper clip because it fits through the holes. You know, it's a little rough on the end. I just put it to each of the four corners of the buttons, twist it around, and gives me a nice little score mark I can find. for figuring out the center point of the buttons. A little hard for you to see me doing this because my fingers have to be in the way, but it is what it is. Come on, you can do it. That goes there. That goes there. That goes there. That goes there. Now, you know, I could measure it, I suppose. But, again, me, math, bad. I am also serially awful at measuring things and getting them indexed correctly as to where they actually go. Finding the edge of something in relation to the edge of something else, and I'm really horrible at that. I'm just the worst. So that's why I'm doing it this way, because this is precise and doesn't require any math, any rulers, or anything of that nature. So those should all be scored, and hopefully they are. So hopefully I don't have to do this again. So then we'll take it out. And this one's out. And this one's out. And I should have little score marks. Yep, they're hard. It might be hard for you to see, but there are little dots all over the place inside there. And a nice, pretty little grid. So now what I can do is I can make little or little lines between them, find the center point, and drill my pilot holes. So how am I going to do that? I think I'm just going to kind of eyeball it. Basically, you cross between them, and wherever they cross is going to be your center point for that button, more or less. And I'm worried that when I screw this one, or when I drill this one and this one, there's not going to be enough material in between those. I don't know. We'll see. Plastic enclosures are cheap. The hard part's done. That's the hard part. This is just fabric cobbling at this point. And we score this one. I don't know, does that even show up on camera? Yeah, you can kind of see what I'm doing there. And score that. This last one's a pain in the butt because it kind of goes right between, right over the words here. But it looks to me our center point is going to be similar to right in the middle of that. Our center point's right at the top of that M, which makes sense. So I'm going to take our pointy tool. I'm going to gouge that to give a nice spot for the drill to bite into on each one of those. There we go. Okay. You can see that how I got that set up. Tiny little drill bit. I want a small one, but not super tiny one. There we go. That'll work. Haha. Yeah, I have 2 drills I keep down here. This one for unscrewing stuff, and this one for drilling stuff. Part of my toolkit, I also have one of these in the car, and I also have one in the garage, so I've got one wherever I need it. Get that bit in there. We'll get these started, and this is going to be tricky because, you know, I don't want to drill down through my bench here, but just kind of get it started, and then we'll drill through it by hand. That's one pilot hole done. next one. Make sure my finger's nowhere near it. Yes, okay. There's another pilot hole. Of course, because I'm really bad at positioning things, that hole is way off, but whatever. This isn't like precision engineering or anything. Here's the next pilot hole. And the last one. Last pilot hole. Nope, that's not the last one. The last one's down here. So that's the last of those 4. And yeah, you can tell they're way off, but whatever. It's close enough. The last one goes right in the middle of the M of Hammond. There we are. It's one of the tricks I've found to drilling plastics. Make sure you have nice, clean, sharp bits, and go kind of slow. Don't put too much pressure on it, or else it just shreds it and chowders it up. Okay. So let's find a bit here that works well with these buttons. YouTube magic, spare button. So I'm almost thinking, looking at it, that my biggest bit here is probably the one I want, because it's going to be basically the size of the whole button, and then the whole button might just fit through, and then I won't have to do a lot of finagling with the knife or anything. So we'll just do that, because why not? And as you can see, the cleaner side is the side you drill from. The back side is always going to be the nastier side. So now that this is the front-facing interface side, the human interface, we will drill it from this direction. If this bit will fit, I should say, if this bit will fit in my drill. There's junk on it, so I think I've used it before. Yep, it fits. Okay. And here we go. It's going well. Hold on just a second. Do I have something I can put under this that's going to protect my thingy? Big piece of metal. Do I have a big piece of metal? Gonna go off camera for a second. Hold on. Big piece of metal. Big piece of metal. I don't want to use that piece of metal. That goes to one of my computers. Ah. Yep. PCMCIA card adapter. It's big. That'll work. You can tell I'm not going too hard, not going too fast. I'm just taking my time, drilling through that. Make sure I'm going to clear. Yes, I do. Yeah, it by default should clear that. Yep. And pop right through. Clean on the top. Looks pretty clean on the top. Does the button fit through the hole? Almost. It almost fits. So I just need to do a tiny little, like a ream job. That didn't sound right. Strike that, reverse that. I need to put the drill in there and go around with it to clean that out. But we'll do that last. All right, next one. Let me make sure. Yep, it's going to clear that. Mmm. Chips. Ooh. I almost screwed that one up, but it's okay. Yep, we'll have to do a little sharp knife action to take care of that. That's okay. All right, next one. And so another thing that happens, you get going too fast and it binds up and goes, and you do weird things, so don't go too fast. Don't push down too hard either, because that can also cause bind ups and stuff. Get our curly cues. It's adorable little plastic curly cues. It smells like Legos in here now. All the plastic dust. Hold on, I'm gonna get some of the stuff out of the way here, because I know I'm gonna be blowing things away with air, and I don't want to lose anything. Thinking ahead a little bit for once, surprisingly. There it is. Wanted to get those screws, because those exactly match that, and I don't want those to go anywhere. Put that over here. Get this out of the way. I don't need this anymore, or just not right now, because it's just in my way. Put all the tools away, blah, blah, blah. There we go. That goes there. Diodes are done. Okay. And we continue. Okay. I'm going to try test fitting this real quick. I just want to see what it looks like. That's pretty close. Yeah, again, like I said, I'm going to have to do a little adjustment of those holes, but that shouldn't be too big of a deal. It's right on the corners. And then they'll pop up right up through those holes. That'll be cool. Yeah. Uh-huh. Check the chat. Nobody's saying anything. You guys are quiet. Talk to me. Talk to me, Goose. Tell me what you think. Yeah, where's my knife? There it is. Yeah, we'll see. We'll have to get in here with the knife and cut around the corners and stuff. Like that, very carefully. Yep. But, yeah, we'll get to that. Okay. Ooh, that one's really close. It's really close to that other hole. That bothers me a little bit. We'll be able to drill that and drill it a little bit south of there. Yeah, these are these two were the two that were close to each other. I'll see what I can do. Can I get it depiloted, so to speak, now that I've screwed it up? Not really. Nope. It is what it is now. Yeah, we're alright. We're alright. Just have to be careful, because these two holes are a little bit closer to each other, because I didn't pilot them very well. That means, although there's plenty of material here, this is going to be a lot thinner. So I want to be careful with that. I mean, if we end up blowing that away, it's not the end of the world, but it just makes it look not as pretty. I suppose I could have gotten round buttons. That would have been easier. Noted for next time. Yeah, I managed to get it offset a little bit. Yeah, I managed to get it to off the pilot hole just enough. That's good. Getting really close to the end. And there we are. Yay! Okay, that worked. That's not bad. Could be better, I guess. Could be worse, too. That knife sharp. Yep. Just get the chowder out of the holes there. That looks pretty good. Let's do the last one. Yeah, I think that'll be alright once we get those holes cleaned up. Yeah, you can see, and this one's off a little bit, and yep, it'll all be good. Toaster King, just checking in to see how much fun you're having. Oh my gosh, we're having crazy amounts of fun. I was just saying, hey everybody, talk to me, and you're the first one to talk to me, so that's great. Lots of fun. As you can see, we're making confetti. We got to the part to where we have this completely done, and we're making the enclosure for it so we can put that together. And I was just lamenting how this would have been a lot more intelligent if I had, I don't know, bought round buttons instead of square ones, because now I gotta cut the holes out, but whatever. So that's where we are. We're just drilling the last hole in here. Yep, we're good. Just realizing you guys can't see what I'm doing, can you? Because the drill's right on top of it. Sorry. That's just how the way it's going to be. Almost through. Yep, that one didn't come off very cleanly, but that's all right. Okay. Nice. Okay. So we got our holes. That's pretty close. You can see, I mean, they almost fit. There is not a lot we have to remove on there. So I have a tool we might be able to use for that purpose. Be done with the drill bit. Be done with this thing. Get rid of our fuzz just because it's dirtying up our workspace. Okay. Fuzz is gone. How about a square a square drill bit? You know, you say that as a joke, But I swear, gosh, it was about a year ago, I saw a video, short little video, of some specialized milling equipment to actually drill square holes. Now, they're not perfectly square, it's more like a rounded rectangle, but the corners, the diameter on the corners is absolutely tiny. So it's basically square holes. So, yeah. But as you can see, in my shop here, I don't have room for a gigantic fricking $28,000 milling machine, so that's not going to happen. So we just make do with what we got. So that's good. So let's do the thing here. We're going to get the magical rotary tool, the Dremel. That thing. And my bits, because I think I know the exact tool I want to use to attempt this. Okay, let's, can I get this thing apart? Is my thingy in there? Hold on. Where is the thing? Where's my wrench? Wrench. Wrench. Okay. Get that cutting wheel out of there. And the thing I want to use is this little side rotary bit here. Allow me to just nick the edge off the corners of those holes and we should be in business. Now, warning, this one might be a little bit noisy because Dremels are known to be loud sons of guns, so yeah. Alright, let's see what happens. Not very pretty, unfortunately. But we had to try it. See if the button fits through it. Yep, sure does. So we can just very carefully round that off a little bit. Take the edge off. There's our square hole. Kinda, sorta. Kinda, sorta square. But it'll fit. Haha! Now to do it 4 more times. Noting that if we put that in there, it's on this one I have to get the top edge more than the bottom edge. Okay. That in there. Ooh, yeah. Might as well square this out, though. Might as well, right? Make them all square holes. Ha 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 ha! Sweet. A few more times. Okay, we'll do this one next. Probably just square them all out and just be done with it. Oops. Oops. Scratch the front of it. Look at that. We make mistakes. We move on. It's not perfect, but it is what it is. We'll just live with it. Alright, those are the worst buttons ever, or the worst holes ever. But it works! Yeah, I made those holes way too big. That's okay. It's fine. It's fine. Just trying to clean those up a little bit. Ugh, plastic dust. Don't breathe that. Ugh. I have to sweep the floor after this one, that's for sure. So let's put this in here. Do all the buttons clear? They do, and look, they're up from the surface. So they're easy to get to, they're easy to feel. Yes. There we are. And then this, you know, we'll have to put the little end caps in there, but then this goes in there like that. And it falls out. No. I was just realizing, completely random, unrelated to this project. Does that or does that not look like an Atari cartridge to you? Hold on, I have one. Just thought of something. Don't I have one up here somewhere? I think I do. Hold on. Ha-ha! I found it! Look at that! Well, the resemblance is there, but it's not uncanny exactly. That's fine. So, last little bit of something we need to do. Oh my gosh, we're almost at 3 hours. This is crazy. So, the last thing that we need to do is we need to get our bus connected in here, right? Or our feed wire, as it were. Go over here. Get out of my way. That's this thing. And so my thought on this was I was just going to cut that and wire it up to that in there like that somehow. And then create some sort of strain relief on that. Yeah. And that I would do strain relief probably by using a zip tie and tying it around there, and then it'll bind up against this backer plate, right? And it won't come out. That's the idea, anyway. I also thought of, when I was doing this, I thought that I might also wire up, where are they? Here they are. Oh, come here. You can do it. Those instead as my push buttons, but they don't have pretty buttons on them. But they have LEDs in them that I could have wired in series with the button. So when you push the button, the LED would light up, and then in theory, the LED would also act as one of the diodes for the circuit. Pretty schnifty-like, but I decided not to do that again because these aren't very pretty. But that would be really cool. You press the buttons and they light up. Or I could have used the lighted buttons and maybe put these end caps on those buttons. I don't know if they'll fit the buttons. They might not. Nah, they don't fit the buttons. Although that would be cool if I had used end caps, because then I could have no, that wouldn't have worked. I take that back. I was thinking that they could be lighted all the time so you could use them at night. But this thing, it doesn't have a ground path. There's no ground path here, so I could have like wired them through so they'd be lighted all the time. They'd only be lit when you press the button. Probably a feature on the deluxe model. Deluxe lighted remote. Anyway, so I think that's what we'll do here. What I'll probably do is cut this and sheath a buttload of it, and then wire them through the top side of the board like that, and have them come out this side, and then I'll solder them on from that direction. That way I can hold on to those while I solder them so they don't come out. And then also that bend will act as extra strain relief inside the hole there. I think that's what we gonna do. So, and it doesn't really matter how much as long as I give myself plenty to work with. Remembering that blue, we just wire it that way. This left side here is our power wire. If we plug this in, not that side, I mean we plug this side in, and the blue's on that side. It doesn't really matter that much. Actually, white is on that side. I got that backwards? No, blue's on this side, yeah. Just remember, blue is going to go over to our red side when we wire it through. It doesn't really matter, because this wire crosses over either way. It doesn't really matter. Because it crosses over. Yeah, it's a crossover connection when you look at it. Well, in theory, well, it might be. For all I know, when my guy put this on, he wired it backwards. You can see these are different connectors. They're slightly different. So when my guy crimped it on, he may have crimped the wrong end on. But that's okay. If it's backwards and he goes to use it and it doesn't work, we would just cut that off and put a new end on it. We would just do that and put the new end on it. Because if it's backwards, it literally, because you'll be feeding voltage up through the 0 line. It would go there, and you would only ever light like the other, coming up through 0. So if you press that, you would get nothing, because you would be going against the diodes. Nothing would happen. Okay, no, it doesn't matter. We'll just do it the way I want to do it and deal with the consequences later. So cut that off there. You get a dumb magic tool for stripping this kind of wire. And I'm just going to give myself plenty. I didn't cut through it. Wow, that did a bad job. That crimp tool did a horrible job. Let's not use that. So let's do it my way. Think of it like this. So it's going to come up the top. Yeah. Yeah. Doesn't leave me a lot of room to zip tie that. It'll be fine. Yeah, we're fine. So it's going to come up through underneath this way, which means we need plenty to wrap all the way around. So basically we just need this distance. Yeah. That's exactly what I thought. Oh, that worked much better. Okay. So blue, we want on the red side. This is where I might use some tape to hold this down. I want to strip these and solder these first. No. I want to get them through, then strip them and solder them. Because if I try to strip it, solder it, and put it through the board holes, it might not work well. Yep. So basically, so it's, I want to basically go all the way up here. Yeah. So we are one. This is going to be pain in the butt. Super pain in the butt. I'll figure it out. One. Two. 3, 4, 5, and 6. Haha! Success! Is that enough wire to get down to my bus wires? It's perfect. It is absolutely perfect. Okay, I'm going to take you. We're going to tape this down so it stays out of my way. And so it doesn't go anywhere while I'm working on it. Yeah, it looks about right. 3 hours! Oh my gosh! Super long live stream extravaganza. Sunday, Sunday, Sunday! Oh wait, it's Saturday. Hold on. Wire's kind of pulled out a little bit. Let's get that back down in there better. There we go. As a matter of fact, when I'm done, I might just leave that tape on there. We'll see. Okay. Now we strip and solder those in place. Strip and tin, I should say. They're perfect. See? Like I knew what I was doing. Kinda. Not really. Fake it till you make it. So we want a 22 gauge on that, probably. And the green one. The green one didn't go because it's being a stupid. Don't be a stupid. There we go. Red. As you can see, this is just telecoms wire. It's just a 3-line telephone cable. Red. Black. Black did not strip well. Let's try that again. You go out of my way. There we go. Black. White. Make sure those are good. Might be too short. Yeah, black's not quite right. Should say, not too short, too long. Yeah, blue's too long. Yep, we'll strip a little more. I misjudged it. That's okay, that kind of thing happens. That's good. Okay. Yellow. There we are. Green. Green. Red. If you're ever working on telephone stuff and you're trying to remember which wire goes where, remember red is ring. RR, red ring, and green is tip. That red needs a little more off of it. Green one's good. There we go. Black needs a bunch more. And white. There we go. Okay. Twist them. Okay. Those are twisted. Twisted! Throat's a little dry. Do I have any coffee left? Coffee. Okay. So that's hot. Yep. So let's tin these suckers. Red one do? Yeah, it did. It did do. It did do. Ha! Look at that. I melted my wire on my Dremel. Here, for security and safety, let's unplug that and get that out of the way. Let's not have 110 volts on the bench that I could just destroy. Oh, that would be spectacular, wouldn't it? You'd love to see that. Maybe we can do that. Yeah, we'll put 110 volts across a capacitor and see what happens. I've already done that in one of my videos. Go check it out. It's the one called Technopendence Day. It's pretty nifty. Basically, they just explode. They just go boom. Okay. Those are all pre-tinned. All we got to do is fold them down, melt them on. I'm going to trim these a little bit just so they're not hanging off the end of the board. That one's in. Next one. Next one's a little long, so we'll trim it again. Reflow the solder. Yep. That one's on. Trim it a little bit. Reflow the solder. Trim it a little bit. Reflow the solder. And trim it a little bit. Actually, that one doesn't need to be trimmed. That one's perfect. Reflow the solder. And there we are. Our cable's wired up. Sweet. Good, good. Now, I am going to do a test just to make sure I don't have any cross connections between any of those, since they are very close together and have like layers of wires connected to each other. Continuity. Okay. Nothing on those. That's good. That's good. That's good. Oops, I touched them together. That was false. And then this one I have to be careful because I could get a false set, so to speak, because we have buttons here. Because this is the power line, the final one here. So I gotta be careful that don't press that down. Good. No cross connects. Sweet! I should probably test again that all my buttons give the correct codes. I'm going to just go ahead and do that again. Because why not? Might as well. Make sure I didn't screw anything up because we reheated all these joints. Things may have become disconnected. That works. Diode test. We should get these two. Yep. And then for this one, we get 1 and 2. Yep. And for this one, for foot up, it should be 3 and 4, which are these two. Yep. For foot down, should be 2 and 3. And for massage it should be 0 and 3. Yep. Everything's still good. Yeah! Awesome! So, what is next on the agenda? Trying to figure out how to put this together. Yep, that'll go like that. And then, you figure out how to make us a little hole in that. That shouldn't be too hard. Yep, that'll go either way. It doesn't matter. Is this one stiffer? Is this one got... Yeah, this one's got more oomph to it. I like this one better. It's got a little lip on it. It's stronger. So we put that in backwards. Marker from marker. Figure out where it's going to go. And that's the little bit we need to cut out with our magic Dremel gun. So let's do that. 8 people watching. Oh my gosh, it's been 3 hours. 3 hours and 16 minutes and people are still watching me fabricable plastic junk together. That is amazing. I don't know how or why anyone would want to do such a thing, but I am friggin' grateful that you do. That is awesome. So let's let the drilling commence. Yeah. Yep. So just a little shy of that, not too much. See if that's enough. I want it to be tight again for extra strain relief. I want it to try to push that wire right up in there. So you don't want it too loose. Need a little bit more than that. Just a little bit. Oops! Multimeter overboard. You go there. I should also be done with my solder. So the solder is going to go away as well. It goes up there. Just a little more Dremel on this. Not too much. Stay symmetric! It's not symmetrical. It's bothering me. Okay. Try this in here. Oh, come on. You can do it. Not quite. Almost there. A little bit more. There we go. That's more symmetrical. Much more symmetrical. Joey like. Okay. Ah, there we go. It pinches that in there quite nicely. Yep. That's pretty good. Yep, that's in there nice and tight. Now it's on the top side of it, but that shouldn't be too big of a deal. Okay. Looks good. We're pretty much done, kids. However, I am still going to see if I can have room to fit, nope, that's backwards, a zip tie on that. I'm paranoid. I don't want this to come back for any reason. Yep, I think I have a little bit of room to put a zip tie on that. Just a little bit. Let's try it out. So this goes in here like this. That board is basically, the end of the board is basically flush level with this, how can I put it, this right here. So if I align my zip tie to that, that should work. Okay. Okay. That's pretty close. Now we just need to snug the absolute crap out of it so it itself doesn't slip off. Okay. And then, for giggles, I'll put another one behind it to help hold it in place. Mm-hmm. Yep. Just like that. Okay. Sweet. Now we've got proper strain relief and yank through protection. Now will it go in there and fit in there and not be a butt? Of course it's going to be a butt. Of course it's not going to collapse all the way down correctly. Because of course it won't. Well, poopy. Yep, that's not going to work. That is unfortunate because basically, because this board is pretty flush against that, you can see I can't push that down in there. It leaves a gap in here where the screw holes go, which is not what we want. Because then, yeah, it just looks dumb and the buttons catch and yeah. Mm-hmm. So we're gonna try something else. I'm gonna use tape, but I'm also gonna use hot glue. I know that's a stupid way to do it, but I want to try to keep that held in there. I wish I could I drill holes and zip tie that way? I wonder if I could drill a couple holes here and zip tie it across the whole thing. Yeah, but then that won't give enough pressure. That won't, yeah, that won't work. Yeah, I don't like that. Okay. Hot glue it is. Hot glue's your friend. Hot glue fixes everything. Like Quinn Dunkey says, Blondie Hack, she's like, I usually, when I'm faced with a problem, I usually just throw microcontrollers at it till the problem goes away. And that's me with hot glue. I just throw hot glue at it until it's in one piece. So that goes there. I don't need the Dremel anymore, I don't believe. So we just have to wait for that to heat up. Okay, so while that's heating up, I'm going to test fit this. I just want to see what it looks like. Make sure the buttons don't bind, they don't stick at all. There's enough clearance so that they don't bind at all. They don't get stuck underneath the casing or anything. Nope. That's good. So our test fit will be that panel in there, right? Yep, basically. And then we would need the other panel on the other side, and that would go in there like that. And then that goes together. That is pretty slick. Joey like! Okay. So we get all of our screws at the ready. Okay. We don't need those anymore. While that's heating up, we'll take a quick little, just short little break, a little sabbatical side cam. Yeah, there we go. So, yeah, that's where we are. We got that thing put together pretty nicely. What are we doing here? So, yeah, we're heating up the heat gun. We're going to melt some hot glue on that just as some extra strain relief. And we'll put that back together, and hopefully the end cap, the Dremeled end cap there that I made, will act as extra strain relief on that, and that'll be helpful. And then we screw it all together and we're done. And then, you know, this thing's going on 3 hours and 3.5 hours now. Maybe after that we'll sit and goof around. I'll chat about a couple things and some things I got going on. Some other stuff I might want to do. Yeah, I'm not very good at ad-libbing. That's why I'm not in comedy or entertainment per se, but whatever. This shirt, by the way, if you didn't know, Radio Shack sells these now. You can go to RadioShack.com. Not that I'm not sponsored by them at all. I just think this is nifty. You can go to RadioShack.com and buy one of these and get yourself a TRS-80 shirt. They also have other types of things available of that nostalgia. So Radio Shack actually exists again. They kind of went bankrupt and came back, and went bankrupt and came back, and went bankrupt and came back again. And now they're selling things like Arduino kits and stuff like that, and some of their original catalog items as well. So I think that is pretty nifty. Don't have a Radio Shack here in town, unfortunately, to go visit and look at, but whatever. Coffee. Oh no, it's empty. The world is ending. Other things to mention, again, I have mentioned it a couple times. Maybe I have some new people that have come on the stream, and a couple ever have left. I've had about, 8 people on the stream, and I love every single one of you guys, by the way. If you haven't heard, though, but I've got a Twitter account here, so if you want to follow what's going on with me, you can do that. And also over here, I have a Patreon account. Again, $1 or $2 in the cup helps me out. That helps me fund all of this magic here. As I say on my Patreon thing, this hobby costs money dollars, and time is money dollars, and everything is money dollars. And right now I fund it just with my day job. And while, I can do that, obviously, it's not the end of the world. My hobby is my hobby, and I like to be able to separate the hobby from everything else in life. And you showing your support for me by pledging on Patreon there really helps that out. So, done shilling for myself there. Let's get back to it here and get this finished up. The glue gun, I think, is hot. So, do we have gunk coming out the end of it? Huh? Yep, pretty much. That is mostly working. So let's get this all gooped up here. Let's see here. Just get tons of glue. Tons of glue everywhere. Glue all over the place. That's not quite hot enough yet. Yeah, it's not quite there. We'll give it another couple seconds. Yeah. Yep, another couple seconds on that. In the meantime, I'll do a little housekeeping. I'll get my soldering iron out of the way here. This goes up there. This goes over here. Put my tools away. Anything to kill time. Anything at all to kill time. Oh, I still need that. I don't need this. I don't need this. I don't need this. Remember, when you're done, always clean up everything. Get everything off your bench and out of your way so the next time you don't have a mess. That out of the way. Mm-hmm. Cool. Are you hotted up now? Yeah, that's better. Okay. Lots of hot snot down the side there. Get it underneath the cable. And then we go over top of it a couple times. And then I'm going to use this to kind of flatten it down. Because we have to deal with, again, making sure we maintain clearance there. Because this is the tight side. Of course, that's not going to hold much, but it is what it is. Melted some more on there. Poor man's strain relief, but it is what it is. Pull down faster. Hot glue. Not quite yet. I want to let it get fully solidified before I let go of it, or else it's just going to peel up away from there again. There we go. That's good. All right, here we go. Final assembly. Lid goes in. Ah, yeah, the hot glue presses right up against that, which means that'll act kind of like as a rubber sticky. Keep it from going anywhere. I have all 4 screws. Yes, I do. This one in next. Yep, it's nice and tight. It's almost like this like adds extra pressure here as a press fit. That's gonna do a really good job at keeping that in there. I like that. Here, let's not get the wire underneath that. Let's not do that. That would be bad sauce. Oops. And the final one. Last screw. Ooh, that button's bound up. Ooh, Joey don't like that. Why is that button bound up? Oh, because the whole thing is situated to one side. So we'll loosen it all up and get that moved around a little bit until they're not bound. It's exactly what we don't want to have happen. We don't want any bound buttons or any bindable buttons. May have to Dremel that one hole a little bit bigger. Didn't bind up during the test fit. That button is just bound. Hopefully I didn't break the button. If I broke the button, I'll just end it. We'll just end that part and I'll fix it later. Okay. Take that back apart, take a look. No, button works. I didn't get glue under it or anything. Why is that not any good? Dust all over the place. Yeah, I'm gonna Dremel the top corners of that out just a little bit. Just a tiny bit. Not too much. Loud noise alert. There we are. That should clear. That should clear! Still this left side over here. I mean, if I journal it all the way that way, it should be okay. I don't feel like journaling it again, so that's exactly what we're going to do. And we'll put this one in on the cross. Doesn't bind, doesn't get stuck. Nope, that's good. That is good. We like it. All 4 screws are in there and tight. Check it one last time for binding. No binding. All the buttons are clear and free. Ha-ha! Kudos! Okay. Get these little things in here. That's good. Yep. This one goes on this side. And this goes together like this. Yeah, here it is, the moment of truth. We're almost done, folks. That one's in. This one. And the last screw. one completed, reversed engineered, handmade, fabric cobbled remote for a Craftmatic 2 Model 2 adjustable bed. Oh, that is just crazy. Wow. Magic stuff. Whew. 3.5 hours of work. You know, plus all the work I did ahead of time to, you know, do some research and put that together and all of that stuff. So yeah, this is just, that's just flippin' cool. So the only thing we have to do now is give it to the client, and hopefully it works. And we know it works electrically. We know that the signals at the bottom of the board are the same as the signals at the bottom of this board. So the only thing that could be backward is this connector, because the way this was wired is one side had the blue at the left and one has the blue at the right. That might not be the way it needs to be wired. It may need to be where blue is at the same side. So if that's the case, if he takes this home and it doesn't work, then we cut this off and we flip it around and put it on the other way. And that should do the business. In the meantime, we're going to go ahead and I'm going to put his original remote back together, as it were, sort of, a little bit. Because, yeah, for all I know, my remote is a piece of crap and won't work. This remote does function, it just functions very poorly. So go ahead and stick that back on there. And where's the pieces? Here they are. This goes in here. This kind of sort of goes on here, not really. He taped it together. And I just so happen to have the same kind of tape. Duct tape is your friend. Okay. A couple little pieces here just to stick this together, since that's what his expectation is for functionality. Ah! Hello. Let's see. There we go. That's together. Piece on the other side. There we are. Alrighty. There we are. One fixed remote. Well, that was fun. Hope you all enjoyed it. I don't know if the rest of you want to sit around and chat for a while. Don't really have a lot going on in the live chat. Apparently it's not much to talk about. It's just stuff to watch. Maybe you're listening to me in the background. Maybe I'm Bob Ross this evening. You know, thank you for watching the land of happy little accidents, or whatever. But that's cool. Yeah, stuff coming up on the channel. I'm planning on doing more of these chill streams. I like to just, this is something that I do, you know, a lot of this stuff behind the scenes when I'm working on my computer stuff is I'm just sitting here at the bench messing around with things and goofing off, doing whatever, getting into the bits and pieces of these old computers, and you don't see it on the videos. All you see is this YouTube magic final product where all the mistakes have been removed and it's all spliced together and it looks pretty and it's got these titles and all that stuff on it. But sometimes that's just boring. It's like, ooh, look at this produced thing, but you know, you don't get the interaction, you don't get to watch me work and see my process. So I'm wanting to do a few more of these chill streams. I got some ideas for them, you know, just little stuff. Playing around with some coding and stuff on JCM1 might be fun. I want to build a sound engine for it, like code a sound engine. On programming JCM1 makes it actually quite easy to do that because I have the serial-based, I have the monitor working and the serial-based input. I can just throw code to it, and so I can screen share that. You can see what I'm doing while I'm typing it on the screen and see if it works. Be pretty cool. I have an Apple II. If any of you follow me on Facebook or you're on the Apple II enthusiast group on Facebook, you may have seen that I recently acquired 9 fully functional Apple IIe's, with the exception of one. One has a bad RAM chip, and I figured, well, that might be a good project to desolder a RAM chip out of that and fix it and put it in there. Just stuff like that, so you can see what goes on in some of these processes, and you can learn a little bit more than just, hey, I fixed it, and more of, hey, this is how you fix things. You know, because it's, when you think about this stuff, it's not just about preserving the stuff and keeping it working. It's about sharing those processes with you guys out there so that you can learn how to also be preservers of this old awesome hardware. And you know, maybe if you have some of these old 8-bit computers and they're acting flaky or weird, instead of being like, oh, I can't, and just having this broken 8-bit, you can start to learn how to get into it and fix it and diagnose it and do all that stuff. Learn how to read schematics and resistor values and blah, 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 blah. So you can fix your old computers and keep them working. If I can learn how I learned to, or how can I say it? If I can learn to do that stuff and then teach you what I've learned, I think that you know, will go quite a long way of helping the entire community out, and that's kind of the entire point. So there's not a lot going on at this point. I think it's time. It's getting around 4 hours. Everybody's probably starting to get sleepy and want to go ahead and take off, and that's fine. I do appreciate every single one of you that stopped by this evening. Let me know how you heard. Like, let me know in the chat or in the comments after this goes live how you heard about this live stream. If it was just the YouTube thing pinging you, or whether you saw one of my other social media posts about it. I want to try to find the best way to let you guys know when I'm going to be doing the live streams in the future, so that you can show up and watch them. Other things, again, Twitter, you know, follow me there. Patreon, drop $1 in the cup, help me out. And that's it. I hope you enjoyed it. If you did, hit like, subscribe, hit the bell, do all of those things. That really helps the channel work. And remember, 8 bits are all you need.